Great. So let's get started. We'll jump right in. I want to start with an assumption. If I can get my slides. Okay, great. Which is that languages are interfaces. That is, programming languages are interfaces that people can use to write computer programs. And therefore, they should be subject to the principles and methods of human-computer interaction. And so for the rest of the tutorial, we're going to talk about, well, what are those principles and methods, and how can we apply them to programming languages in order to improve our programming language designs. So I want to start with some kind of age-old design questions, just to kind of motivate our discussion here. Some of you probably have strong opinions about these. In some cases, probably everybody in the room will agree. In other cases, we'll probably have some strong agreement, and strong disagreement. And the point is not to start a religious war. The point is to observe that there are these kind of open questions, and maybe human-centered methods could try to address some of these, or could have been used to address some of these before they made it out into the world. So the first thing I'll mention is actually, Jonathan, do you want to do this part?
Sure. Yeah. So I guess you'll have to scroll through since you're presenting. Okay. So yeah, the number of design questions. One is maybe famously considered a mistake: dynamic scoping in Lisp. Obviously, not something that we would implement. We would use today, but it was easy to implement and kind of the obvious semantics at the time. Maybe getting a little bit deeper might be, questions like laziness in functional languages, right? A much more maybe rich kind of design question, much more controversial, right? I think there are people who would say, you want strictness because it's predictable, because perhaps you feel you can get higher performance, but on the other hand, laziness gives you flexibility. It gives certain kinds of semantics. Programs terminate that wouldn't otherwise terminate. And so, that's a deeper question and maybe a harder one to answer, but it's one that continues to be, debated. Right. So, other kind of controversial design decisions, equality types in SML, right? What can you use equals on? There's a well-defined rule. Functions can't be compared for equality, for example. But is the kind of structural equality with identity for references and nothing available for functions the thing that you really want, right? And of course, every language that is designed, practically every language has built-in equality into the language in some form, or perhaps put it into the standard library and allowed people to define it. So it's another kind of deep design question that is controversial and is probably not going to go away right away. Another quirk that came up in some discussions we had beforehand was things like the order of evaluation of function arguments in OCaml, right? Which turns out to be right to left because it was the most efficient way to implement a stack-based interpreter at the time. So that's a design decision that was maybe made for reasons that are out of date now, and has certainly caused some trouble over time. I think one question that's interesting to me here is, how does one resolve these questions, right? Laziness and I think might be a hard one, just because it's so broad, it affects so many different things. But maybe there's ways you can get insights on part of it. And one of the questions I'd encourage you to think about right now is, could consideration of users more explicitly in a language design have caught some of these, right? I don't know about dynamic scoping, but perhaps we could ask users what they expect to happen with equality types and get some guidance. If we go back in time, 30 years, 40 years perhaps to the beginning of standard ML and some of these other languages, and we don't know what to do with equality, could we get an intuition for what what users expect, and combine that with mathematical ideas about what equality should respect, which of course also play in. Perhaps if you asked users about the evaluation of function arguments, that you would have gotten a pretty obvious answer that right to left was a bad decision, right? That might be the most obvious one, the one that's most obviously amenable to user-facing methods. There are some broad questions that usability methods have had some influence on. One question is our types useful, right? This being ICFP, there's a large contingent that probably are fans of type languages like ML and Haskell, and probably a large contingent that might prefer the Lisp family of languages, right, or dynamically typed languages. What's the evidence? There's too much evidence actually to put on one slide. There's a lot of studies. Many of them show that there is some benefit from types. Some actually show that there isn't. And what's interesting is that it appears to depend on the setting. It appears to depend on what task you ask people to do, in a typed language versus an untyped language. In some tasks, we see benefits from types. Others we don't, and perhaps we see benefits from dynamically typed languages. Perhaps more interesting is the question, how are types useful? And what the evidence that I've seen shows is that, for example, the documentation benefits of types, the fact that you can look in a library and have automatically checked documentation of what the inputs are, what the outputs are of functions in the library, may be more important than the correctness benefits, right? The bugs you find with types are often quite small, but the ability to understand a library quickly because of types might be much larger. And so some of the studies many of the studies that show advantages are showing the advantages because there's library usage happening. And so, there's that benefit of documentation starts to show up. So one related question is that some people sometimes ask us, and it's a good one to get out at the beginning of the tutorial, right? Can user-centered methods actually impact fundamental language design decisions? I think there's maybe a trope or a stereotype that HCI methods are for what the color of the button is on the web page, right? And the equivalent in languages is maybe what's the right keyword to use, right? Okay, but the crazy thing is when we design languages, many people here perhaps design languages or thinking of design languages, design type systems. We usually do that at a level of abstraction well beyond where the keywords exist, right? So, how does this actually help us, right? Can user-centered methods affect fundamental decisions? When I mean by fundamental, I mean something that has a big effect on the formal system, on the type theory of the system. So I think this is still emerging, right? We haven't applied a lot of user-centered methods to programming languages over the course of history, but we're starting to do it some. So Michael and I have designed a couple of systems. One is Glacier, which is an immutability type system for Java. So two examples of decisions in Glacier. One was the decision to support transitive immutability, right? So there's a lot of design choices in immutability. Other people have investigated read-only references, sometimes called reference immutability, where you say, okay, I can't change a data structure through this reference, but maybe there's other references that I can change it through. Other people have looked at non-transitive immutability, which is immutability for a single object, rather than transitive immutability, which is an entire reachable reference graph from an object. And so we actually did some interviews with experts, and they basically told us transitive immutability is the most important abstraction that we want to support. And when we furthermore did user studies where people tried to implement transitive immutability, because we said, okay, based on the interviews, this is the important thing. We did it in an existing system, IGJ, which is immutable generic Java. people found it difficult. The reason was IGJ didn't have a direct abstraction for this is an immutable, a transitively immutable data structure. Instead, it had a set of primitives, and you had to put them together to get what you wanted, right? In fact, one of the things that immutable generic Java had was genericity, parameterization by immutability types. And we found out that this actually created a lot of complexity. It posed a major barrier to usability. Could people actually express immutability with this, as well as correctness? And so we said, okay, parameterization is actually a barrier. It's making things worse. It's something that is kind of counterintuitive because it adds expressiveness. Obviously, parameterization would do that. But we found out we didn't actually need it because most data structures are entirely immutable, or else not. And so we made perhaps a controversial decision, but it was a decision that was driven by these user-centered methods. And it was successful both in the sense that we were able to implement larger case studies without the parameterization. We didn't have very much code duplication coming from this, just because of the nature of the domain. And we were also able to later show through double-blind controlled experiment that, controlled experiment. I guess blinding is hard to talk about in this area, but it was a randomized controlled experiment that our system people were able to be successful in our system much more than without it in plain Java, for example. So in this case, the decision seems to be successful. And that was, of course, things like do you support parameterization, things like the semantics of immutability as a transitive. Those are things that do have a large effect on the formal system that we developed based on these ideas. So one more example on the next slide is in Obsidian. This is a language for smart contracts. So we were looking at an abstraction called type state, where you have a contract and it can go through multiple discrete states, and there's different operations that are valid at different contracts, right? So you have to purchase a bond before you can, get interest payments from the bond. For example, that would be a financial smart contract. So we were looking at type state. Michael, we just switched screens. Can we get? Can I get full screen? Thanks. Yeah.
Sorry. Yes. Okay.
Usability challenges with Zoom and presentation software. Okay, so
it's too many keyboards.
So we previous type state systems that we had designed had type state, which is what state a contract is in or an object is in this case. Orthogonal from permission. So permission tells you that you are the only person who has access to a stateful abstraction. Okay, and so linearity is a kind of permission. So we had linear types on the one hand and type state on the other hand. We kept them orthogonal because we figured, well, that gives you more expressiveness, right? You can mix and match any kind of permission with any information on the type state. But it turns out they aren't entirely orthogonal, right? If you have two shared pointers to something that you're tracking the type state of, then if you change the type state, that's going to confuse, through one pointer, it's going to confuse other parts of the program that are looking at that object through the other pointer. So these appear to be possibly orthogonal. We were able to come up with some abstractions, but they were a little bit complex in previous languages that allowed us to deal with sharing in some cases. But we realized in Obsidian that we could reduce complexity a lot and sacrifice a little bit of expressiveness, but not too much, right? By combining these. So there's a single abstraction in our final design where if you mention a type state, that implies that you own it, that it's linear. And so again, this is a choice that did have a major impact on the formal system. One set of annotations that either you give a type state or you give one of the sharing annotations and no type states. Another decision was to support dynamic state tests. Both of these came from user studies. In the case of dynamic state tests, we found users expected to be able to say, oh, what state is this contract in? This one is a little more arguable. I think we would have pretty quickly discovered we needed it for expressiveness anyway. But definitely the combination of type, state, and ownership was kind of strongly motivated by experience with users and their confusion by, what are these two orthogonal dimensions? I don't understand this, right? And to keep in mind, we're not targeting programming language experts. We're targeting people who maybe, program on the side and might be business experts, for example. So we do want Obsidian to be fairly accessible. These issues of people being confused were fairly important. So hopefully these couple of examples have convinced you that there are cases where user-centered methods can have a fairly fundamental effect on the language design. We found that even doing user-centered methods, it has kind of a side effect of having us focus on these issues in a way that we might not otherwise.
Great, thanks, Jonathan. So let me give you kind of an outline of what to expect in the rest of the tutorial. We're going to talk about what usability is. If you haven't done usability work before, you might find the answer is a little bit surprising. We're going to talk about kind of the methods that we're going to, the context of the methods that we're going to teach, a bunch of practical considerations about how to actually do studies that you can do. Usability studies and other kinds of qualitative studies, as well as quantitative studies, which may be the kind that you are most familiar with. And in several of these sections, you'll have a chance to practice and get some feedback. So let's jump right in regarding the question of what is usability. So I'll give you a definition from ISO, and then we'll kind of talk about what its implications are. The extent to which a product can be used by specified users to achieve specified goals with effectiveness, efficiency, and satisfaction in a specified context of use. So I want to kind of contrast this with maybe a naive definition of usability, where usability is something you measure along some sort of usability scale. More usability, less usability. That's not really what we're talking about here. We're talking about a much more fine-grained kind of property. And so if you want to talk about which system is more usable, you have to say exactly what kind of usability you're talking about. So let's kind of break this down. So, who are the users? What are the users trying to accomplish? In what context are they trying to accomplish it? How well do they actually get it done? And how much work does it take them to do it? And do they like it? These are all usability questions. And so when you phrase a usability question, you need to answer these, kind of meta questions about your usability question. So, for example, when we say who are the users, maybe what we want is to allow not more novice users to do more. Alternatively, maybe we are focusing entirely on professionals who are experts at some particular kind of work, and we're trying to enable them to do their work even faster than they can already, or enable them to do kinds of work that would require different kinds of expertise that they don't have yet. So there are kind of two general categories of methods. There are formative methods, which work before your design is complete. So these help you answer questions like, what problems or goals do users have, and how common are those problems? What are the most significant problems with a design that I have so far? In other words, even though the design isn't complete, I have some design ideas, and I want to know kind of if I'm on the right track, or if there are maybe changes that I should make now in order to make the final system much better before committing to a full implementation. Right? Because if you build a whole implementation of something, you've put a substantial amount of design and engineering work into it, and then if you discover a fundamental flaw later, well, it may really be too late in your project for you to make significant changes. And then also this question of how do users already express solutions to their problems? Maybe they're already doing something, so what are they doing? Can we learn anything from that? In contrast to formative methods, summative methods are good for analyzing designs that are already complete. So you can answer questions like, what fraction of participants can complete some task T in n minutes? And which one succeeded and which failed? Not just which individuals, but how does success correlate with other properties of people? For example, do people who had a lot of professional experience, are they more likely to succeed? Are people with a lot of education more likely to succeed? Or maybe it's the opposite for some surprising reason. Then what is the distribution over completion times for some task? Does everybody who finishes it take about the same amount of time? Or are there lots of people who take a really long amount of time and lots of people who take a really short amount of time? And why is that? Likewise, do more participants succeed if they use language A instead of language B? Or are there fewer bugs if people use language A instead of language B? Hopefully your language is language A and the existing language is language B. A lot of times we want to show this about our systems if it's true. So the overall method that we're talking about here, we're calling PLIERS, the Programming Language Iterative Evaluation and Refinement System. And the idea is to integrate human-centered methods into the design of a programming language. So rather than saying we're going to only use theory or we're going to only use HCI methods, we're going to use both. So at first we do some need finding to figure out what people are trying to do and what they might need. Then we come up with some design using our own experience and our own creativity to come up with some sort of proposal. And we do this both by doing a theoretical analysis, as is maybe typical in the ICFP community, but also by doing low-fidelity prototyping, which maybe most people are also accustomed to doing, writing example programs or writing a little interpreter compile for key parts of the language. And then afterward, then we ask the question, okay, what are the major usability risks in this design? What are the questions that we want to ask so that we can find out what the usability characteristics of this design are? And then by learning what difficulties people have with the system, we can refine the system. So here you see in step 4, you can use empirical methods that we'll be talking about today to drive refinement both of the theory and of the prototype. And of course, the two of those go together, and then we iterate with more empirical methods. So we find some usability problems, we fix the system both in the theory and in the prototype, and then we reevaluate to see whether whether there are additional problems that kind of come to the surface. And then when finally we are satisfied with that, we do some kind of summative assessment to see whether we have succeeded in achieving the design goals that we had. We were trying to make a language that's better for this kind of person and doing that kind of task than some existing system. So, okay, let's do a comparison with that existing system and those kinds of people and those kinds of tasks to see whether we actually succeeded. So, I want to kind of step through the different components of the usability definition so we can see how these are kind of interesting questions and ones that are useful to refine. When we talk about users, people are, of course, multifaceted. So what kind of education do they have? What kind of experience do they bring? What do they know and what can they do? Right, knowledge and skills. And then in what context are they doing the work? Are they in a large project? Are they in a small project? Are they in a quiet room, or are they on a loud factory floor where they have trouble focusing for a long period of time, that sort of thing? A mantra that we use in HCI is the user is not like me. So it won't surprise you to hear that most programmers are not like ICFP participants. Most programmers kind of out in the production world are maybe only barely aware of functional programming. They deal with mutable state all the time. They use not the language that they find most satisfying, but perhaps the language that their manager told them to use. And they haven't heard of linear calculus. And furthermore, even if you are specifically targeting functional programmers, they may differ from you in other ways, right? They may be kind of practicing functional programmers and not programming language researchers. Or they may be SML people and you may be Haskell people, or vice versa. So if you assume that the user is like you, then you are designing a language only for yourself. On the other hand, if you assume that the user may not be like you, then you open up a much broader audience to your language. You will change yourself over time, and yourself in a couple of years may not be the same you are now. And so if you design for people more generally, you might appreciate the changes that you made also. So, okay, who cares? My language is for people like me. Well, I argue that language is actually a communication tool for humans, used over a period of time. Inevitably, software needs to be maintained. So if you design the language just for you, well, people may not be able to maintain the system. I once worked in industry, and we had an intern who wrote a little tool for something in Haskell. And then a couple of years later, we found a bug, and we needed to fix the bug, and nobody knew Haskell. So we had to throw out the tool and basically just either rewrite it or do the job manually, because it wasn't worth learning Haskell just for this one little tool. And more generally, we want to broaden participation in computer science and software engineering not narrow it to people who are just like us already, right? So if we want to design programming languages for more kinds of people who maybe are not currently empowered to do programming, then we need to understand who those people are and what their needs are, rather than just assuming that they are like us. So I'm going to show you a tool that is used in HCI in order that is used to kind of help think about people. So these are called personas, and the idea is to group characteristics that are common to people in your target audience into buckets. So the idea is to kind of help you think like the user and build empathy for the user by kind of putting these characteristics in a persona who is not an actual person, but is somebody who you can think of as a prototypical user, and you can reason about what kinds of systems might be useful for them or not useful for them. So I'll give one persona that I found. Charlie is in her late 20s to mid-30s. She has a bachelor's degree, but not necessarily in IT. She's a self-taught developer. Her coding is unconventional, and she mixes genius lines with simple errors. She seeks to reinvent her software development career, but the how is still unclear. Charlie has a family, which makes financial stability and work-life balance essential. She's new to the industry, and thus looks for a company that offers a supportive, people-oriented environment where she can learn and improve her skills. So you can see there are details here that are not directly relevant, I'll say, to programming, right? Who cares whether she has a family when you're designing a programming language for her? On the other hand, it helps you think of her as a person with whom you might be able to empathize and think, okay, if we want to address Charlie's needs, here are some things that we might try. And then you go do a user study with people like Charlie, and you try to evaluate whether you've succeeded. There are personas by CLARKE that were developed at Microsoft that have been used in developing various kinds of programming and software engineering tools. Like every persona, these are flawed in various ways, right? We're not suggesting that we're going to find one person that exactly fits each particular persona, but that these personas help us reason about different groups of people who maybe think differently, and in particular may think differently from us. So there are three categories here. The first one is called the systematic developer, who writes code defensively, does everything they can to protect their code from unstable and untrustworthy processes running in parallel with their code, develops a deep understanding of a technology before using it, and prides themselves on building elegant solutions. In contrast, we have the pragmatic developer, who writes code methodically, develops a sufficient understanding of a technology to enable them to use it, prides themselves on building robust applications. Notice the contrast between robust applications and elegant solutions. And then finally, we have the opportunistic developer, who writes code in an exploratory fashion, develops a sufficient understanding of technology to understand how it can solve a business problem, and prides themselves in solving business problems. So the idea is we want to avoid judgment here, right? We're not saying we want everybody to be like this kind of developer, and those other people should take a hike, right? Instead, we're saying, look, there are different kinds of people in the world, and we're going to try to address their needs. Now, you can say, look, this system that we're designing is really for this kind of person, and other kinds of people, maybe they can use other systems. And that's fine, but it's a deliberate design choice. And so by using the personas, you can think about that explicitly. Okay, now goals. Well, what does the user want to achieve? So you can kind of investigate goals by starting with a vague goal and kind of drilling down. So, you can say, I have a C programmer. Okay, what do they want to achieve? What are they trying to do? Are they fixing a bug? What kind of bug are they trying to fix? Or what are they trying to implement? Or you can say they're understanding code, but why are they understanding code? Are they fixing a bug? Are they doing a code review of some other code? What are they doing? Next, in terms of context, are they starting from scratch, or are they maintaining an existing system? Are they working with a large team, or are they working on their own? Is this the beginning of the project, or is the project really almost about to ship, which speaks to their level of risk averseness? Is this a one-off task, in which case they're not probably willing to put in much effort into automating it? Or is this a repeated task, in which case maybe they're willing to put in some effort to learn a tool or build a tool in order to make their life better? Next, how well do they do it? So what do we mean by this? Well, you could count and describe the mistakes that they make. You could try to measure how readable their code is if you figure out what you mean by readable. You could ask what fraction of the target population can do it. And then finally, how hard was it? You could measure what fraction of the participants succeeded, or how long it took, or what obstacles they encountered along the way. Or you could do other measures. This is kind of interesting, actually. So when people are stressed, they sweat a little bit. And so you can actually measure this with galvanic skin response. So you can actually attach electrodes to people's skin and then measure whether the task that they're doing is one that they find stressful. So it's a form of emotional response. Or you can measure EEG. You can put electrodes on people's heads and try to measure to what extent you are providing cognitive load. Cognitive load is a measure of typically of how full their working memory is. So as you force people to remember more and more things, cognitive load increases. And then eventually, if you try to force people to remember more things than they can, then they start forgetting things, and they have to go use external memories, like they'll write things down, or they'll go retrieve the data from wherever they retrieved in the first place. And so this takes extra time. And also, do they like it? So this is kind of interesting. If you talk to a participant and say, "Hey, participant, thanks very much for participating in the study with me over the last day. Really appreciate all your time. This is the system that I've been working on for the last 6 years for my PhD. I've been working really hard on it. Tell me, did you like it?" And of course, the answer is yes. Of course, I liked it. Right? People tend to report that they like your system because they want to be nice and they want to help you out. And so if people just say that they liked it, that's not very meaningful. And there's data on this. We find that respondents are about 2.5 times more likely to prefer an artifact that they believe was developed by the interviewer, even when the alternative is identical. And then this discrepancy is even larger when the interviewer is a foreign researcher requiring a translator, which I thought was kind of interesting. So then you ask, well, so what if they like it? Who cares? Well, it matters a little bit, because people are probably more likely to actually use something that they actually like. And if you can report in your paper that people actually liked it, then sure, why not report that? On the other hand, maybe you really don't care whether they like it. So, it's a question that you should think about when you're designing your studies. So the key takeaway here I want to leave you with from this part of the discussion is that there are many different kinds of usability. My more usable system might be better because it's more learnable, or because people perform tasks better, or they're more likely to finish tasks, or maybe a new kind of person can complete the task, or maybe something else. So as you think about what kind of usability objectives you have, you need to first refine your question in terms of what you mean by usability. Okay. Are there any questions about this section before we move on to talking about methods? You can unmute or you can type in the chat. You can jump in at other times too, but I figured I would pause for a moment.
This is Mike Hicks. I typed something into the chat, which it looks like Jonathan is responding to. I mean, do you in general want us to enunciate questions we've put in the chat, or do you just want to ask and answer them as you guys trade off?
Oh yeah, good question. To be honest, I haven't been having trouble following the chat while I'm also talking. Do you want to, rather than having me read this, do you want to summarize if there is a pending question that hasn't been resolved?
So I think the questions have been going back and forth. A couple of quick summaries. One is there's a question about posting the slides, which we'll do. Some interesting discussion on the history of dynamic scoping and Lisp, and a link. Thank you, Hiro. And most recently, Michael and Chris brought up the question of the Sapir-Whorf hypothesis, which is the idea that languages influence thought. And the idea in Rust, as Michael said, is that a language that that has Rust's constructs, for example, to track resources and memory use in the type system, forces people to think about design in a way they previously didn't have to, right? And I just pointed out there's some very interesting work coming from the linguistics community. Lira Boroditsky and others have kind of an updated version of Sapir-Whorf that is more refined and really emphasizes that your language doesn't prevent you from thinking thoughts, but it can influence you into focusing on certain things that you wouldn't otherwise focus to. And I think that's a good principle for language design to think about, again, from a kind of a human point of view.
Great, thanks, Jonathan. Yeah, Lyra Burditz gave a really great keynote. Oh yeah, you mentioned the keynote. Okay, great. Anything else? Okay. Yeah, and feel free to jump in off mute for clarification questions, so we don't, if in case I say anything that's confusing, I don't want to lose people. Okay. So I want to give you an opportunity to try a breakout room for just a few minutes. It says 10 minutes here, but let's try to keep this to 5 minutes so we can catch up a little bit. I want you to identify a usability question that you have about a common programming language. And I say common programming language just so that we can all kind of have a common vocabulary here. If you pick something really weird and identify a usability problem, then we can't really talk about it.
What are interesting questions you might have about usability of a functional programming language? Any brainstorms? Or I guess any language that you're designing.
So how about type inference?
Ah, yeah, that's a great question. What can we ask about type inference?
So because it has been a big research question, but the error messages are often not understandable after type inference for many users.
Mm-hmm.
But so there are proposals to improve, but I haven't seen any real usability research on such research about various improvements of type inference. Of course, there are theoretical results, but it's not about users.
Right. Yeah, I think that's a great question. Inference is something that you could imagine positive effects. You have to. I guess the most obvious thing is you have to type less. That's maybe the smallest effect. A larger effect is maybe programs become easier to change. So you could maybe ask about how quickly people can perform certain software evolution tasks in a system with type inference versus without. But then as you perform that task, maybe you get an error and maybe you're confused. And the question is, does that slow you down so much that it compensates? It actually makes things worse. So I think that's a great question. And one thing that I've found is that when you study these questions, you sometimes find effects that you weren't expecting going into the study.
I mean, my own opinion is that the error messages are kind of throwing people off. Like, I think it's the whole IDE system that needs to reflect stuff well. There's a lot of effort spent on making like the words the error messages would say make sense when most people don't even look at them.
Right. Yeah, having the IDE be able to make connections between for type inference, at least classically in ML type inference, it's an inconsistency between two or more different parts of the program, right? And so having an IDE be able to navigate that graph, it does sound like it might provide a lot more leverage than you could possibly do with the textual error message.
Yeah. I mean, this is just coming from experience with sometimes I've used this language called ATS that my advisor wrote, and
Mm-hmm.
the error messages are by far the worst in any language I've ever used. But it spits out the AST basically.
Okay. Wow.
So it's completely unhelpful, and it's a dependently typed language, so it's not even a little bit like helpful as far as the text goes. But is this being recorded? Then ATS is great. But
I'll cut out the personal comments in these.
Yeah.
No, don't worry.
But the textual information, the actual regions that are highlighted in it, are extremely precise.
Mm-hmm.
So between the almost useless error message that was, and I hooked it up to like some kind of IDE to like actually paste the red squigglies, you can triangulate like it's unnerving how like accurate it is. Like it's like one parentheses opening, one parentheses closing, and then one little bit of text in the middle, and you can figure out exactly what the thing is wrong with it usually. So I don't know. I feel like a lot of people focus too much on the text of the error message when there's a lot more UI space to be figured out.
Yeah, that's a great question and a great point. And it's interesting that usability methods were, I think, first developed for tools and are kind of, in some ways, they're finding their way into programming languages via software engineering, right? Which has been looking at them for a little bit longer than we have. But I think it's a very natural place to look. Any other ideas, comments? I know we have a few other people in the. Oh, I guess it's just the three of us in the room at this point. Any other questions that might be interesting to talk about?
So let's say you're writing your own language and you don't have a lot of time. If you could get something useful out of this that you can only spend like maybe a couple days on, what would be the most, like, what would be the way to use this in a way where you're like very much on a budget? Like, I'm writing a language, I don't even have a parser yet, never mind, nice usability things. Like, I can't complain about error messages, the thing just,
Yeah, so we'll get into this a bit in the next section, but one thing you can do is if you can write a short tutorial on the language and then ask people to do something in it, some very small task, you immediately get some feedback about things that are confusing. Or even you ask them to just read a sample program you've written and interpret it, tell you what it does. So you can, with some pretty lightweight things, you can get some of the high-level questions or confusions people have pretty quickly.
Thank you all for returning. Does anyone want to summarize some interesting questions from the group when you were just talking?
This is Mike. I'll go. We just talked a little more about Rust and usability, and my personal curiosity about how some of the challenging features in Rust have been made amenable to programmers. And then the conversation wound around to how context really informs the setting of when we were doing research on Cyclone, for example, in the mid-2000s, and today is different. We also Chris talked about some of work she's been doing at looking at computational biology and those folks as programmers, and how that audience is, say, much, much different than a general purpose audience. And then Chris was saying something at the end that I couldn't quite understand because of the Zoom impedance, if she wants to summarize.
Yeah, now I'm trying to remember what I said. Pronouns they, them, by the way. So I was saying, basically that there was a keynote at Strange Loop within recent years that talked about kind of popularity of programming languages from a social sciences point of view, and how there's kind of a difference between, or like how often there are differences between how a programming language gets picked up if you try to kind of appeal to a mass audience versus appeal to very specific niches, where like a niche will be a smaller audience, but they will be a more enthusiastic audience and will be more helpful towards like kind of establishing and building a self-sustaining community. So that, yeah, I guess that was just part of the conversation around like the role that community plays in how usable / learnable people perceive a programming language to be.
Great.
We had some interesting discussion in our breakout room. Ihiro or James, do you want to summarize? Sorry, not James, Mark.
Summarize the talk about error messages?
Yeah, error messages and inference in particular, type inference.
I was just sharing my opinion that I think there's a lot of missed opportunity for IDE integration kind of stuff in that area.
Mm-hmm. Yeah, often there's a continuum between the language and the environment and one can study both and of course make improvements in both that definitely increase usability. So we also talked about type inference as a specific example of error messages that can be challenging, and an overall kind of trade-off between the benefits you might get from evolvability that you get from not having to change the types in your program as you evolve it, versus challenges you might get from type error messages, and then ways of maybe improving those either through the messages themselves, or as Mark mentioned, through the surrounding IDE.
In the room I was in, we talked about the value of syntax highlighting and the difficulties of parenthesis matching, especially for newcomers. We were talking about OCaml as one example. Anyone else in my room want to comment? No comments. Okay. Okay. Anybody else? Okay. Great. Well, let's move on to methods, to part 2, which is a methods overview. So I'm going to be talking about a variety of different categories of methods to sort of scope out the space for you. So we basically have 2 categories. We have qualitative methods and we have quantitative methods. And in qualitative work, the focus is on obtaining deep data. This doesn't suggest that we're not going to count anything or not use numbers or anything like that. These terms are not as crisp as one might expect as a computer scientist. But the idea is we're trying to study something in a deep way so that we can obtain insights that we can use to, in our case, refine our programming language. In contrast with quantitative approaches, the focus is going to be on statistics. So you might want to compare languages A and B and show the language A is better for some definition of better by doing this statistical analysis. And today we're going to focus primarily on the qualitative studies. They're typically easier and lower cost to run. By lower cost, I mean they just take less time and you need to spend less money on recruiting participants. They're a great way to identify problems with your language very quickly, and they let you iterate rapidly. So for example, in a qualitative study, you may be able to make changes in your design after every participant. Whereas in a quantitative study, when you're comparing A versus B, you can't make any changes at all between participant 7 and participant 8. Because if you do that, then you'll have to throw out the first 7 participants and start over. So we will discuss quantitative studies briefly at the end, but this is not a class on statistics. So you will need statistics knowledge kind of from elsewhere or by consulting with others in order to kind of put a quantitative study into practice after this tutorial. So let's start at the beginning. You'd like to generate some hypotheses. Like you want to improve a language, and you might have some hypotheses about how to make the language better. Or you have some design space, and you'd like to identify a good point in the design space. So how do you get started? So for example, I hate how people keep inserting these race condition bugs when they program at C. So what should we do about that? Well, there's a lot of things that we could do about that. And you may not even know that race conditions are a relevant problem yet. All you know is the workers in the factory would like to be more productive, and they're not quite sure how. And the factory workers are doing some amount of programming in the factory, but you don't know very much about what it's like to program in a factory. You've never done it before. So we don't want to just come up with any old hypotheses. We actually only want to investigate hypotheses that are likely to be true. However, you can publish a paper even if all you have is a hypothesis, even if it's if it is a well-defined and well-supported hypothesis. There are workshops, for example, HATRA, which Chris and I are co-organizing with Luke Church, or Plateau, which other people are organizing, are both good opportunities to publish these kinds of things if it's preliminary work. The deadline for these is not passed, by the way, so I encourage you to think about submitting. But what do you do if your brain is empty? I mean, you don't have any hypotheses yet. You just know that there's some space in which you want to do some work. So what do you do? So there are some stages of design, of research. You start with maybe, I don't know what I'm doing, in which case you might want to know what problems are there to solve and what hypotheses are worth testing. Then eventually, maybe you have a prototype tool and you want to make it better. Or you have a tool and you think that it is better, but you want to show that it is. For this last question, but because qualitative studies are so versatile, that's where we'll be spending most of our time today. So in general, we want to understand something that we don't understand yet, like what problems do factory workers have, given that we don't have any experience maybe personally in that situation? Or what is it like to write code for race cars? There was an ICSI keynote on this topic, actually, which is why I bring up this example. I thought it was kind of interesting. It's a kind of extreme, I can't use the term extreme programming, but it's an extreme environment in which people are writing code. And maybe they have different programming language requirements than in other kinds of contexts. Or, I think my system is really great, but I'm not sure that it's really great. And in any case, I want to see if I can make it even better. So, if you want to answer this question of what usability problems do people encounter when they use my system, which I think is awesome, then you can do a usability study. So in this first part today, we're going to be focusing on how to do usability studies. And in a usability study, you give people some tasks, and then you see what happens. These are not experiments. They're not comparing two different things. There's no particular variable that you are tweaking, other than you give people this entire system, and you want to know what happens. With usability studies, you can show things like some percentage of my participants did complete the task in 30 minutes if you don't make any changes between the tasks. But maybe more importantly, participants encountered the following problems, and we were or were not able to address those problems. Or possibly only participants who knew X were able to do this task, and so we're going to rescope our solution around people who have those particular kinds of tools. So for example, here's some results from a study that we did. We had this type system where some references are only references. This is related to the system Jonathan was talking about earlier with type state. So we gave people some tasks. One participant asked, what happens when passing an owned object to a method with an unknown formal parameter? And the behavior was that ownership was not passed in this case, but the participant wasn't sure. And anytime the participant isn't sure how the system works, you can view that as a usability problem. Another participant said, when I annotate this constructor type owned, I'm not sure if I'm making a variable owned or if I'm transferring ownership. Right, again, something about transferring ownership. Here, another participant was surprised that an assignment from an owned reference to an unknown type variable did not transfer ownership, which at that time in the language it didn't. So you can see how you make all of these decisions when you're designing the language, and it's not obvious what people will expect until you try, and then you can be surprised. So the conclusion was ownership transfer was confusing. We tried to solve this by making changes of ownership explicit, but then this made the language very verbose. You always had to have these change of ownership operators sprinkled throughout the code. So the revised solution was to specify the ownership changes in formal parameters, and then in assignment, you always transfer ownership when possible. Before, it depended on the type of the receiving variable, that is the L value. We simplified it to say, look, it just depends on assignment on the type of thing on the right, which is maybe a little more clear. So you can't show with usability studies that your system is better than a particular system. Again, these are not comparative studies. For that, you need statistics and quantitative studies. Did you have a question? Okay. All right. So now I want to talk about some practical details of how you actually run a study. And after that, we'll talk about how you design the tasks of a study. But this is kind of important context for how you actually run a study. So suppose you want to argue that your results generalize to some population. For example, you're trying to target, well, in my case, I was targeting blockchain programmers. So you want to somehow argue that you're targeting blockchain programmers. Or maybe you want to argue that you're targeting professional web developers. Then what you should be doing, if you can, is recruiting participants from that population. But in many cases, that's very challenging, right? So first of all, we have no way of actually sampling in a fair way from any developer population, right? There's no list of all of the professional software developers out there from which you can sample. It's not like political polls where they can, call random numbers and get a random sample, which itself is problematic because of cell phones, etc. And the fact that people may differentially choose to answer their phone depending on their perspective. So what you can do instead is argue that some other population from which you can sample is similar to the population that you did sample from. So, for example, one thing that we've done is there's a Stack Overflow developer survey that observes that over 40% of professional developers have less than 5 years of professional experience. So, well, master's students frequently have some professional experience. So that's great. So maybe master's students are actually representative of some kinds of professional developers. So how are we going to actually find these people? Well, you can put up flyers in a geographical area if you want to recruit from a particular region. You can send lots of emails. You can use your social network. You can buy ads. You can do Google AdWords. You can do Facebook ads, whatever ad service you want. You can literally go out on the street and try to get people off the street. Now, if you're trying to find professional programmers, that probably doesn't work unless you're standing outside an appropriate office in Silicon Valley. Although you could try that, maybe that would work. But if you're looking for end-user programmers, that is, people whose main job is to do something else, and you're building a system for them, maybe random people on the street could be a great sample for you. I went to a Dogstuhl on empirical evaluation of development processes. There's a report from that Dogstuhl that has a bunch of recruitment ideas. So I encourage you to kind of mine that report for some ideas if you're stuck. Now, okay, it's one thing to find some people who you'd like to participate, but how are you going to actually incentivize them to participate? Well, sometimes you can just pay them. It can be hard to pay professionals enough money to make that a real incentive for them. A better incentive might be to convince them that they're going to contribute to science by helping you, or just that you're a nice person and they're going to help you on that basis. You can feed them. Sometimes just giving somebody lunch or coffee is enough to help people know that their time is being appreciated. An interesting approach that I haven't tried personally is fame. So if you have a leaderboard, you have some sort of contest, and then you have a leaderboard, and the idea is people who participate can rank high in the leaderboard if they do well. So this both encourages people to participate and encourages them to do a good job in the study. On the other hand, you might change who you're attracting by having a competition. So you have to kind of think about that aspect also. One suggestion at the Dogstuhl was you can offer a rare experience. Like suppose your university has a nuclear reactor. And you say to participants, look, if you participate in my study, I can arrange a tour of the nuclear reactor for you. I hear those kinds of tours always get glowing reviews. So, if you have something kind of rare to offer, you can try that approach. Or sometimes a learning opportunity is good. I'll teach you about something new. Or if you're recruiting from people at a company, and you can have them do this as part of their job, they may be very happy to get a 10-minute or 1-hour distraction from their main job to do a little job for you. Maybe they're tired of doing whatever they're doing all day, and they're happy to to contribute in a different way. So lots of different ways to incentivize people. Then, okay, who? Well, there are lots of different kinds of people. If you're working on a programming language design, obviously you might want programmers, but there are lots of other kinds of people too who are involved in developing software who might be relevant. For example, testers or security teams or designers, experts in the domain that you're targeting, requirements engineers. So think carefully about who you want to use to evaluate your system or to give you feedback on your system. It may not just be programmers. Okay, now there's an ethical question in incentives. What if the incentive is too high? So this is kind of interesting, right? You might think, well, a higher incentive is better because you'll get more people. But the problem with an incentive that's too high, well, there are kind of two problems. One is that you can sort of get a mob of people who are trying to participate in your study, and maybe they're even like sort of competing. So a classical example is if you go to a place where there's a lot of poverty and you pay them a lot, they may it sort of results in an unfortunate competitive situation if you can't give your incentive to everybody who's there. Likewise, you may, sort of separately, people may be willing to cheat to participate in your study, because it's just so attractive. So you have to be sort of careful about that. On the other hand, if you give an incentive that's too low, well, then you're sort of exploiting people. So that's not fair either. So the institutional review board, which should be approving your studies, should in part be looking at your compensation to make sure that it's reasonable. They also check things like, is recruitment clear and honest about, for example, the costs and benefits to participants. So IRB reviews the recruitment materials typically to check that. You can do pre-screening on your participants. You can issue a pretest, for example, to avoid wasting time on unqualified participants. IRB typically likes to review the pretest. There are some issues, though, right? Like, how will you incentivize people to take the test? And can you use the test results in your research? So what I typically do is I do informed consent before the pretest so that I can report on the data collected during the pretest. Otherwise, you may not be able to use that data in your research if you didn't get informed consent. So just some examples of pre-screening questions that I've used. Which of the following might be a valid Java constructor invocation? Because we wanted to make sure people really knew at least a little bit of Java before participating in the study. Or in Java, encapsulation refers to which of the following things? Or here's some code, what does it do? Or here's some basically Java trivia, can you answer these trivia questions? So you can see how if people are sort of too incentivized because of a very high payment, they might be motivated to kind of cheat. So it's important to kind of keep these things balanced. Okay, so I think, Jonathan, you can say what you think. I'm thinking we're going to skip this recruitment exercise just so we can get a little bit back on schedule. Jonathan, do you think we should do this, or do you think we should move on?
Yeah, I think we have a later exercise on task design, which maybe is a little richer. We could have a short conversation just all together here on this. Maybe using one or two of the examples from the previous breakout rooms.
Okay, sure. Does anyone have any thoughts on who you might try to recruit for those examples and how you'll try to recruit them?
As you recall, one example was looking at some of the usability questions involved in Rust. Another one was type inference examples. Sorry.
Oh, sorry, those examples.
Or anyone you come up with is fine.
Well, one thing I was thinking was we've been running a programming contest for a while to try to see what methodologies work for secure software development. And ideally, it would be fun to run this in a class where, one part of the class builds their program in Java and the other part builds it in C, and then you see how things shake out at the end. But then there's this both an incentive and an ethics problem there because people's grades now depend on their performance. And that performance depends on what other people in the class are doing, and they might have friends, and so they don't want to harm their buddy's code, or maybe they really don't like the other people and they want to harm it for that reason. So like a really good population is kind of ruled out by this ethical concern. Just an observation.
Yep. And recruiting in classes can be really effective, but it can also be subject to exactly the ethical problems that you were just discussing.
Yeah, I think I think it's fairly easy to get. There's a couple things you can do. One is you can certainly get qualitative information, right? If you let people opt into, if you have two sections and you're maybe upfront about the way that you're teaching in each section, but it's different, then that eliminates the ethical concern to some extent because the students can choose which section to be in. But then, of course, you have different potentially self-selection effects. And so you may not be able to use it as an experiment, but you can use it to gather qualitative information about, improving your solution, perhaps. You can use it to form hypotheses that you could, which may not be true because of the differences in population, but which you can then later test in a more rigorous setting. I've also seen people do experiments longitudinally. So you offer a class in one year, and then the next year you offer the same class, but with an intervention, and you compare them. So then you don't know for sure that there's no difference between the classes, but it's a less strong selection effect than if you just sort of allow people to go one way or the other.
Yeah,
I guess for that, you have to be able to argue that, oh, this is a change we believe is beneficial, so it's not going to hurt the students.
We did a study comparing two different tools, and what we did in the class as one of the assignments is, look, you have to use each tool to do the same problem twice. And so then there's this question of learning effects. If you did it once over here, is it much easier over there? But in terms of education, it means that people learn both tools, and maybe depending on what your learning objectives are, maybe that's valuable. And then you can do a comparison between the two tools. You counterbalance the order. Half the students do A first, half the students do B first, and then you can try to see what the learning effects were. And then you can have them opt in for the research study. So everybody does the assignment, everybody uses both tools, but you can't use their data in research unless you get them to sign the form. But at that point, everybody's already done the real work. So my experience was, if you chase people down aggressively enough, they'll be happy to sign the form. I just mean, if you ask somebody to fill out a form and you don't follow up with them, then they may not do it. But if you keep reminding them, eventually they're usually happy to fill it out.
Yeah, aggressively is a funny word to use in this context.
Yeah, I don't really mean aggressively, but yeah. Okay, great. So some practicalities. If you're in academia, you need IRB approval. IRB makes sure that the ethics rules are being followed. Their main job is to weigh the benefits and the risks of the study. So in a programming language study, typically the risks are very low. You're not asking people to take a dangerous drug, and so you're not worried about side effects. The worst kind of injury is probably going to be some sort of repetitive strain injury, but you're recruiting people for a few hours, maybe not for a few years or a few months. So that particular one is not that significant, but there's no such thing as a zero risk study. So you just need to be honest and forthcoming about what the risks of your study are, both with IRB and with the participants. And then people are allowed to make their own informed decisions about whether they're willing to participate. So you can say, look, there's a small risk of repetitive strain injury, but you may also learn something about programming if you participate in the study. And also, if you participate, we'll pay you N dollars. So we hope you'll participate. And then people can decide. And of course, people need to be free to leave at any time. So if they get halfway through your study and they feel uncomfortable, then they need to be able to go. And then you can say what happens. Do you pay them half? Do you pay them full? Do you not pay them at all? Again, you just need to be clear about what the rules are so people know what they're signing up for. In general, people can agree to a wide variety of things. Like, for example, if you want to attach electrodes to their head and measure EEG, you can do that if you get their permission and you get IRB's permission. Right? It's all about what kind of consent you have that governs what you can do in your experiment. So here's an example consent form that we used in a recent study. We say what the purpose of the study was. Let me see if I can get a little highlighter here. So we say can you see my cursor? Yes, you can. Okay, good. We say basically what happens in this study. You'll be asked to complete programming tasks. There's an interesting game that is played here. It takes a bunch of work and time to get an IRB proposal through. So if you propose a very specific study, you say, here are the materials we're going to use exactly. Then if you want to change any of the materials, then you have to go get reapproval. On the other hand, if you propose something that's too vague, then IRB isn't really able to assess the risks, and so they won't approve it for that reason. So there's a little bit of a balance between giving yourself enough wiggle room to refine your tasks as needed, but also saying what you are going to do so that IRB can make a fair risk assessment, and also so that participants can know what they're getting into. So here we say, you'll be doing programming tasks. you'll be either helping us refine our design or comparing it to existing approaches. So you can see how this protocol covers both a quantitative study and a qualitative study, because both involve programming tasks, and we've said there are these two alternatives for what we're going to do with the data. While you're working, we'll record audio and video. We may also use an eye tracker, and then we give some information about confidentiality. So what's going to happen to the recordings, and what can we do with the data that you produce? You know, can we use it in publications? Can we publish videos of you? If you know, you can get permission to publish videos of real people, but that requires that they actually consent to you doing so. So, you know, if you want that or you need that, you can ask for it. In this case, we didn't feel like, you know, videos of people were going to be pretty valuable, so we didn't request permission to video people. We did request permission to record audio and video of the screen, because then we could go back and analyze kind of what happened during the tasks later. If you want to do studies with children, that's a whole other category. And if you need children, then you can get children. But if you don't need children, typically you want to stick with adults. Outlining risks and benefits, you know, compensation and costs. We'll pay you this much if you complete the study. There'll be partial payment if you don't complete the study. Confidentiality, here's what's going to happen to your data. This part here in blue is typical, right? So you record the data, you give each participant a number like P37, participant number 37, and you record all the data under their participant ID, so that when you do the reporting and you do the analysis, you're not really exposing yourself to sensitive data that is de-anonymized. You're dealing with anonymous information. You know, you have the people's names probably if you recruited them yourself, but when you do the analysis and you publish your work, you're not going to reveal people's names. You know, your participation is voluntary. You're free to stop your participation at any point. And then if you have any questions, here's who to contact. Any question about the kind of ethics and administrivia? This is not the most exciting part of the tutorial today, but it's important information to know if you actually want to do any studies.
So I have a question. What if you're not in academia? And maybe this is not relevant enough to take time in this workshop, but
yeah, that's a good question. My understanding is that conferences do not necessarily demand that you obtain IRB approval. And if you're not in academia, you may not have access to an IRB. So IRB specifically is in part a legal construct that comes from, in part, federal funding. So if you're not in academia and you're not getting federal funding, then you may not be subject to that requirement. I
believe that some companies do have research boards, but I don't know the details.
Yeah, some companies do. So yeah.
I mean, I guess I would say generically, informing yourself about the ethics of research with humans is important if you're going to be doing research, just because it's the right thing to do. You're fortunate, I guess, in that you don't have to necessarily fill out a bunch of forms. It can be a little bit of a pain, but mostly the IRBs at universities are filled by they're mostly professors who are on them, and so they tend to be pretty reasonable. But I think if you're outside of the academy, there are places you can learn about the history of research. We have fewer problems in computer science than in areas like medical research, where vulnerable populations like prisoners were experimented on. There's definitely some horrible stories. One was there was a syphilis experiment that was performed on black men without their consent, for example. It's one of the most horrible stories. I don't think we're going to be doing any of those things in computer science, but recognizing, for example, that there are populations that are more vulnerable, and if you're interacting with them, you want to be careful to make sure that there's nothing, you're not imposing any risks on them, and you're not kind of unintentionally forcing them to participate in your experiment, even if you don't intend to. Those are good things to be informed of. There's a class that we take at Carnegie Mellon, an online class, to learn about this. I don't know whether those things would be available to someone who doesn't have a contract with the organization, but I'm sure there's educational materials you can find if you want to learn more. Maybe we can look up some of that and see if we can put it in the slides that we distribute later.
I think there are interesting studies to do regarding programming languages that are not as low risk, right? Like you could ask, what is the effect of caffeine consumption or alcohol consumption on programming? I haven't done any of these studies myself, but those would put you in a higher risk category because you'd be essentially giving people drugs. Okay, great. All right. Okay, so you've gotten consent. You've recruited your participants. You've got people in your lab or in your virtual lab, and now what are you going to do? Okay, well, the first thing you should do probably is collect some information that will be useful regarding demographics. So, and you can collect any data that is relevant and which you have permission to collect. You know, participants can choose not to, you know, give you information if they don't want to. So you can ask, you know, what kind of programming experience do they have? What languages do they have experience with? If they tell you information, then you can use it because now they've given you permission to use that data in your study. So for example, you can ask for somebody's gender. I typically do it like this. There's a blank line and people can write whatever they like. So this is nice in a small study because it's completely free and people can do whatever they want. If you're doing a larger scale study, you know, a quantitative study, and you want to collect hundreds of samples, maybe you want to have a pop-up menu, in which case you need to be careful about what options you provide here. But what you don't want to do is, you know, look at somebody and then make an assumption and then write something down, right, and then report that in your paper. So if you ask them and they tell you, then you can use it. If they don't tell you and you guess, you probably shouldn't use that kind of information. So we gave people a questionnaire that looked like this, with a bunch of fields to fill out, including questions that were relevant to the particular kind of studies we were doing. You know, we wanted to be able to say things like none of the participants were familiar with, you know, these particular existing tools. So if you want to say that, you have to actually ask them. You can't just assume that they don't. Next, how will you prepare your participants? It turns out if you just give people something to read, then they won't. Or they will, but they don't absorb it. So our advice here is to teach whatever you need to teach them, but then also assess. Or alternatively, decide that no training is necessary. If you want to take people from a particular population and then see what happens, that's fine. But if you want them to learn something, then you actually have to teach it and then assess that they've learned it. So we had a tutorial for the programming language that we were teaching. It had a bunch of sections. We initially just gave people the tutorial and said, here, please read this. Okay, now do these programming tasks. And what we found is people kind of skimmed over the stuff and they said, yeah, sure, okay, I get it. And then when they actually needed to do the tasks, they you know, hadn't really absorbed the information. So then we switched over to a model where we kind of stepped them through the tutorial with, it's really a survey instrument, but the point wasn't to collect the data, the point was just to sort of direct them through the tutorial in a methodical way. And we gave them exercises. So, you know, here's a programming problem that we asked them to do. Here's a multiple choice question about a little bit of code. So the point isn't to make them do a lot of programming work here. The point is to kind of force them to absorb the material, similar to how you might if you were teaching a class. Okay. Any questions before we jump into how to actually run a usability study? This is kind of maybe the most critical component today because usability studies are really key. Okay, so now you need to give your participants some tasks, some kinds of things that you'll ask them to do, and then you'll watch what happens and try to learn something about your language. So this is probably the hardest part of study design, and you will not get it right the first time. What will happen typically is you'll design a task, it'll seem totally reasonable, you'll give it to somebody, and then they won't understand the instructions. Or they get stuck on the first step when your research question is in step 5. And you've got to get them all the way to the part of the task that's relevant to your research question in order to gather useful data. And then if they get stuck, you know, that doesn't work. So the solution to this is you have to run a lot of pilots. So a pilot, kind of officially is a study in which you throw out the data. You're doing it just to refine your materials. What I find is if you think you're going to only refine your materials, you might end up learning something anyway. So it's better to just follow the protocol. So get informed consent, compensate them however you promised you would, and then you can use the data if you get good data. You're also trying to find out how long the study needs to take. So, maybe you know how long the task takes you, but that doesn't tell you how long it's going to take your participants. So you need to actually try it in order to find out that kind of information. So, okay, what are you going to have people do? Well, choose something that you think might be hard, but which is also central to the usability of your design. In a usability study, you can't possibly test everything. There's just too many different possible kinds of tasks that they might do with your tool typically, at least if it's a programming tool, because it's, it supports a wide variety of different things. So choose something that is really key to the usability of your system. So some kinds of things you can ask people to do. Here's a specification, please write a program. Or here's some code, tell me, are there any bugs in the code? And if so, what are they? Or here's a bunch of code, but it has a blank section, please fill in the blank section. Or tell me what this code does. Or answer these specific questions about the code. And a lot of the art here, I think, is in carefully restricting the tasks. If you give a very open-ended task, then people will get stuck on things that you're not actually interested in learning about. You're trying to see whether they can effectively use this particular construct in the language, and they're busy writing test cases for the kind of programming problem that you gave them. And you didn't want them to spend time writing test cases. You weren't interested in test cases, but this person's really interested in test-driven development, and so they sit down and they spend a half hour writing test cases. So maybe you want to give them test cases in advance. Maybe you want to tell them, please don't write any tests, or maybe give them a more clear specification so they don't write tests, that sort of thing. And you have to decide how much help you're going to provide. So if you were doing a quantitative study, which this is not, you wouldn't be able to provide any help because you wouldn't want to kind of interfere with the results of the experiment.
Ask a question?
Yeah.
So I was wondering how you design this specification, this task. Do you design it yourself, or you interact with the user, or you also do peer review for this specification? Because I believe this task and the specification matters a lot in terms of the evaluation and the result that you get at the end. What is your approach? What is your best practices that you could share about this specification, design of a specification?
Yeah, this is a really good question. My answer is that it depends on what your research objectives are. So in many cases, you're designing the language to solve some particular kind of problem. You've observed some problem out in the real world, and so then you designed what you think is a solution, and then you want to know, does it actually solve the problem? So then the task should be related to the problem that you're trying to claim that your system solves. Because at the end of the day, you don't want to just show that people understand ownership, like in the example from before, right? You want to show that they can write, in that example, smart contracts. So you're going to give them some kind of task that relates to the overall programming objective that you want to claim about your system. It's particularly good if you can take tasks from the real world. So, for example, if you want to argue that in your system, people tend to not insert certain kinds of bugs, right? Maybe you're designing a strong type system, and it's going to rule out certain classes of bugs. Or possibly, it won't rule out those bugs, but you're hoping that it'll encourage people to think more carefully about their design, kind of like Michael was suggesting earlier, so that people don't make these mistakes. Well, if you come up with a contrived kind of task and observe that people don't make that mistake that you're interested in your contrived task, then a reader of your research might say, well, that task is contrived, and yeah, they don't make that mistake in that task, but of course they don't make a mistake in that task. That task is too simple, or that task is irrelevant. So what I've done in the past is looked at code corpora, looked at bug databases, and tried to find real world bugs where somebody's in a situation, they write some code, now there's a bug in the code. And so then in the study, I give them that situation and that code, or at least as close as I can, to argue that, if people don't make the mistake, using my tool, this is a useful improvement because in the past they did make that mistake with the standard tool. Does that help?
Yeah, absolutely. That the last point was very interesting. Looking at real bugs and the situation these bugs may happen. This is fantastic approach. But also, do you also evaluate? Do you ask others to review these tasks? And maybe do you have a formal evaluation approach for the tasks that you come up with?
We haven't done anything like a formal evaluation for the task. What we've done is, we argue in the paper for why we chose that particular task and why the results may generalize to other tasks.
One thing I would add, so this wasn't in the work that Michael and I did together, but in a previous study, so my previous student, Joshua Sunshine, is now a faculty member as well at Carnegie Mellon. When he was looking for tasks, he actually went to Stack Overflow and he did a whole, it was basically a code repository mining study. So that's another kind of empirical study, not really user-oriented, although it looks at things you find in a repository that was produced by users, so it has some things in common. Stack Overflow is a question and answer site. He basically looked for questions and answers in the category of that his language design was targeted at. This was also type state, so he was looking at questions about Java libraries that had type state, and so he then isolated tasks from those questions. So it doesn't necessarily tell us these are questions that people are asking all the time, but it does tell us they're real questions that someone somewhere asked about this library and had trouble with, right? And then we actually went into the lab and we validated those tasks to discover that, oh yes, actually these tasks do cause people trouble. They're not tasks that people can solve using existing technology in 2 minutes. But they take time and effort, and people get them wrong. And once you find a task like that, then it's good because you have some link to the real world, right, through Stack Overflow, and also some evidence that it's kind of interesting from the perspective of the problem you're looking at.
This is a really good distinction. It's certainly valuable to address a problem that has occurred once, especially if that problem has severe implications. On the other hand, if you can argue that the problem occurs frequently, that's even more powerful. So what we've done in some of our studies is we give people the same task but using the standard tools, and we try to see how often people make the mistake that we're interested in. Right? So if we observe that lots of people who use the standard tool make the mistake in the lab, but the people who use our tool are much less likely to make that mistake, that's a much stronger outcome than saying, our tool prevents the mistake and we didn't see anybody in the lab make the mistake. It's like, well, maybe nobody would have made the mistake even using the standard tool.
Yeah, that's fantastic. Thanks. And you can do all of these statistics with this, right? T-test to provide with whether this tool statistically significant better, right? For avoiding these bugs. Yeah, that's nice practice. Thanks.
Right. And if your tool, if you can show, statically that your tool, or dynamically, whatever your method is, that your tool is guaranteed to prevent a certain kind of bug, then you do your study. You're going to be comparing 0 cases of the bug to some number of cases of the bug, right? And if you can get the other people to make the mistake, a non-trivial number of times, boom, you're done. Of course, people may not be able to use your tool effectively. That's the trick, right? So if nobody succeeds in doing a task with your tool, then it's not clear that you've succeeded. You have to actually get them to use the tool successfully.
Yeah, absolutely. Thanks.
Sure. Okay. Now I want to show you an illustration This is purely an illustration and not data. Okay, but the idea is if you give people a big monolithic task, then people will do all kinds of things that you didn't expect. And so here, what I'm trying to show is the y-axis is some variable that you're measuring, and the x-axis is time. So at the beginning, you start everybody in the same place, and you know what the outcome is going to be after 0 seconds because you're starting everybody in the same place. But as time goes on, behavior will diverge and people make different choices. And the longer you let the study go, the more it'll diverge because people have kind of more room to do creative things. And that's fine, but sometimes you're trying to measure something specific. And some of these things out here that people are going to do may not be relevant to your particular research questions. And so you're watching people who are out here and you're thinking, well, I can't really use this data because what I want to know is kind of along here in this confined path. So one approach that you can take is to divide your task into smaller tasks. And then you can sort of restart people from a well-defined start point at the beginning of each subtask. So you have them do some work and they will do creative things. And you say, okay, thank you. Now suppose you did it like this right here. Now take the next step. And this kind of reduces the amount of variance that you're likely to see. Now, what can you record when you're watching people do these tasks? One key approach is called think aloud, which I'll talk about in a couple of slides, where you ask people to just say what they're thinking as they're thinking it. You can record audio, you can record video, you can capture the screen. These are really useful so that you can go back later and try to understand what happened. You can do eye tracking if you want. And then it's really useful to do a post-study survey afterward so that you can see not just what people did, but how they felt about what they did. Ask them what was confusing. Ask them what they liked or didn't like. You can use a lot of times get useful quotes there that you can report on later. And it's really important to take lots of notes, including timestamps. If you have to go watch the videos later, this can be really time intensive. So in the interest of not having to watch the videos, include timestamps in your notes, which should be fairly copious, so that if you want to go review what happened at 1 hour and 3 minutes into the study, you can just scrub to 1 hour and then watch for 6 minutes and kind of get the context and see what happened. A trick I discovered is that a trick is if you include a clock on the screen, it makes this a lot easier because then you don't have to do math about how many seconds am I into the study and when did they say what they said, etc. Okay. Now, think aloud is really useful. There are kind of two varieties. In concurrent think aloud, you ask people to talk while they're doing the task. And if they stop talking, you can say something neutral like, please keep talking. So you don't want to say anything too leading because you don't want to bias their work, but you want to get them to keep talking. But if you do that, you can't really measure time as a dependent variable in your study because having people do this is going to take extra time. I've also found that it can be distracting for people. Most people will prefer to kind of think in silence. So when I do these studies, I try to balance distracting them from their work and getting information about why they're stuck. Because when you just watch somebody scrolling up and down, you don't really know what they're thinking, right? You have to actually ask. Another approach, which I haven't tried myself but is intriguing, is a retrospective think aloud. So you don't ask them to think aloud during the study, but you record a video. And then after the study is done, you play the video for the participant, and you ask them to do the think aloud then at that time. So the think aloud doesn't affect the timing because you didn't ask them to think aloud during the study. But it does double how long the study takes because then you have to watch this video with them. So that was one of the main reasons why I didn't do it. I was doing 3 or 4 hour studies, so that would turn into a 6 or 8 hour study. But if you're doing a 10-minute study, that might make a lot of sense. You have to think carefully about the contexts in which you're doing these tasks, in which you're having people do these tasks. You can do a perfectly reasonable study just with pencil and paper. You could give them a text editor. You could give them an IDE. You could give them a compiler or not, or an interpreter or not. You could give them a debugger or not. You could provide test cases for them. You could not provide test cases and allow them to write test cases. Or you could not really give them, or you could tell them they can't test their code at all. So which choice you make will affect kind of how generalizable or how externally valid your results are. External validity refers to how well your results pertain to kind of situations outside the laboratory environment. So if you make your study really constrained and really artificial, people may not believe that your results pertain to real-world programming. On the other hand, if you make them too unconstrained, then you may not learn what you were hoping to learn because people get distracted with all kinds of things that are not relevant to your study. And again, I don't mean distracted in like they're off surfing the web kind of way. I mean distracted in like they're writing test cases, but you're not trying to study writing test cases. You're trying to study debugging, for example. So I want to show you an example task that we used in a study. A key part here is that the task description was fixed. So you want to make sure that, you know, when you report on your task and when you compare participants, they all have the same task. And the way to do that is by writing all of the task description down, you know, either on paper or on the screen. But either way, it's not something you're ad-libbing. So what you're looking at here is two different conditions of the same study. So on the left is the experimental condition. On the right is the control condition. And you know, in the qualitative studies, which we did earlier, there was no control condition. We just gave people the code on the left and said, please do this task. And what we gave them was the code on the left minus the code that's highlighted in yellow. So you see there are these comments here around line 29 and here around line 36 that have these to-dos. And so what we told people, obviously the yellow code wasn't here. And we said, we just have these two to-dos here, please fill in the to-dos. So this was after they had been trained in a language, and we wanted to see whether they could complete these programming tasks and what kind of challenges they would encounter in doing so. And then later when we did a comparative study, we added this other condition here. And you can see that it's very parallel. It's a different programming language, but we designed our programming language to be at least similar at a high level so that we could do this kind of comparison. So, you know, I've in the diagram, I've sort of added spaces so you can see the alignment here. But in both situations, the amount of code that people needed to write was fairly short, which makes it a fairly constrained task. People didn't have to, you know, invent specifications or do architecture or anything like that. They just had to fill in this code here. And even this task, you know, you might say, how hard can this be? It's only 4 lines of code they have to write. But, you know, this was a half-hour task, and not everybody finished it. So now I want to give you an opportunity to practice. I'd like you to go to a breakout room and design one task for usability study for a language feature that you're interested in. And for now, you can assume you have a full implementation of the language. You've got a compiler, you've got an editor, maybe you have a debugger, if that makes any sense in your context. And you're going to ask people to do some kind of programming-related task. And I want you to think about what context you're going to do this in, what materials you're going to give the participants, what data you'll collect, and how you'll evaluate their success in completing the task.
So, task ideas. I guess we should zoom in on something something concrete. Anyone want to volunteer a question to design a task for, or a?
Well, I have a really simple one because I'm actually doing. It's not a language feature that I'm developing, but I'm just interested in doing a usability study around how we teach closures and mutable state. And so, I mean that's a language feature, so it could fit in this. In this, you know, world. Mm-hmm. And yeah, it's interesting. I found your comment about going to Stack Overflow really helpful. So it's just like going there to mine questions. Yeah, that's interesting. What are people asking in this world? You know, I just have experience as a teacher teaching it that I know students have difficulty. So it's interesting to try and go see things from the outside.
Right.
That'll certainly help design what we're doing. So I don't have any brilliant ideas about how to design a study, but That's the problem.
Yeah, the teaching question is interesting. You know, there's a lot of literature on educational experiments, of course. One way to think about the qualitative studies is imagine you take you probably have problems you assign to your students, right? Or exercises you have them do in class. One thing you could imagine doing is running tasks like that through individual students and practicing a kind of think aloud with them, right? You could apply think aloud in an educational context and have them essentially think aloud as they solve the problem. And that might give you insight into their thought processes, their misconceptions. Those things often come out in class, as we all know, with questions, but not always, right? Sometimes misconceptions go undetected because people are too shy to ask a question. So if you were one-on-one with several people and you ask them to think aloud, maybe some of those things would come out, and they might point you to, you know, ways you could address those misconceptions up front, or ways you could redesign the problem slightly to help students avoid that misconception, or just to find a way of, you know, how could the exercise be designed so that students get feedback that could address that misconception partway through.
Right. I mean, there's also an interesting question to me, which is, I mean, we're talking about language features. There's also, I mean, the severity of language bugs is an interesting area to me. So, like, how severe is the interplay of, you know, foreign-led in JavaScript and how the semantics is defined? Like, how much of a barrier is that to entry in JavaScript? Anyway, it's there are these little stupid related questions, but I guess it's related to how much would clarifying such things help people.
Yeah.
But anyway, that's a great idea about think aloud. That's very applicable here.
Yeah. You know, the interaction of features, one thing we've done is sometimes try to design a task that leads subjects into it. I don't know exactly how you do that for JavaScript. Of course, JavaScript, there's multiple ways of doing things. You can use let, const. I forget all the constructs offhand, but you know, with students, you could just teach them the one you want them to use, or you could give them explicit instructions to use this, and then give them a problem that requires a for loop and see, you know, how, you know, do students run into the problem, and if so, how do they deal with it? So you can kind of construct the study so that it leads them into the problem. You could say that's unfair, right? Because maybe they wouldn't run into it in the world, but what you're really trying to do is you're not trying to measure the frequency of what happens in the world, right? If you use a different mechanism for that, maybe a code repository study or something. But you want to say, well, if they get into it, then what are the problems from there? Other questions or ideas about tasks?
So something that I've been wondering about is about error messages in Haskell. And actually, I think that this is something that you could distill into quite a nice little task, which is, you know, you have two different versions of the compiler that has, you know, either, you know, you could have today's error message and then some theoretical improvement to it. Hand out to participants erroneous code that triggers that are, you know, preferably maybe sort of several different errors like that all sort of mushed together, and then see both how long and sort of with what. I mean, you could do something more scientific with the electrodes, or you could just sort of do by survey, sort of how difficult it is to disentangle these errors. And I think you'd get useful information from that.
I mean, that'd be a great one for an eye tracking study too.
Yeah.
You know, sometimes one thing we did when we were looking at this kind of a problem, this was actually in the study that started with the Stack Overflow questions. We had the participants do think aloud, and then afterwards we assigned time. We basically looked at the quotes that they uttered, And we used that to assign time to different activities that the user went through. So we were trying to figure out, of the time that they're doing this task, how much is asking various different kinds of questions about type state in our case. So in your case, it might be, how much of the time was spent trying to understand the compiler message, how much of the time was spent trying to understand the source code so that they could interpret that compiler message, how much of the time was spent doing other things that were kind of irrelevant to the task. And so then you could get some sense of how hard it is, how much time was spent on kind of the critical things you're interested in versus other things.
Sure. Yeah, I mean that does seem like a very good way of sort of extracting that out, right? Because of course, in an unfamiliar file of code, there's going to be a lot of time spent understanding the context, which in a more realistic scenario, one presumes that, well, sometimes they've programmed it, sometimes they haven't, but there's going to be more familiarity with the code than, something that I would just hand out to them.
Yes. So actually, a couple more ideas there. James mentioned eye tracking. You could combine that with some of the think aloud work to try to figure out how much time is spent navigating.
Yeah,
eye tracking is good for that. Another thing is, we both talked about familiarity. There is something you can do about that, right? You could give them a previous task that has nothing to do with the error message,
right,
but requires them to engage in understanding the code, make some small edits to the code or something. Now, maybe there's a problem with that if it doesn't type check, but.
Well, I mean, I think you could stage it. You could have the bad part commented out or something, right? So just enough to get here are the data types involved. Here are the sort of the helper functions that you're going to have to use so that the context is in their head. Yeah.
Yeah. And having a task for that, like a training task that they actually do, is better. I mean, maybe it's obvious, but it's better than just saying, "Oh, look at this code and make sure you understand it," right? Because people can fool themselves into thinking they understand it pretty easily.
Jonathan, I'm a little curious with your your smart contract language, or really any of these languages that have type system enforced type state. How do you, I guess Michael was saying you did some tutorials first to try to get people familiar with the language and some of these concepts. The thing that I'm struggling with is if you were to try to test usability, this is a different way of thinking than most people are accustomed to. So you're not just training them on the syntax or kind of affordances, you're training them on a new way of looking at a problem. And I wonder how you do that and tease it apart from the particular, say, language or feature or whatever that you're trying to test. I've just been going through in my head if I wanted to say, I'm interested in this question of, can we get people to stop using type unsafe languages? Can we get people to stop using C++? Or, like mostly. And if the way to get them to stop is to get them to program in Rust, because that seems to be what other people think, how could I try to measure how hard it would be to move from programming in C++ to programming in Rust? So that's a huge problem that you can't just do one study on, right? You're going to have to do this, figure out a task, break it into subtasks, do something very, very small. You're going to have to do a bunch of training if you really want to pick people who are novices and know nothing about Rust. Maybe there's just so many points in the design space there that you could ask about if you wanted to get down to the actual technical question of programming in Rust, how you would do that. And the thing I keep running up against is it's not like C plus type safety, because C isn't type safe. It's not C++ plus type safety. It's totally different. It's type safety is enabled because of the lack of garbage collection in a very different way. And I don't know how to tease apart that different way from other features of the language.
The one thing that I think is most interesting to me in that space is the impact of undefined behavior on people's ability to use a language. So in C, undefined behavior is so crucial to everything about the language. It's like it wouldn't exist without UB. And I just wonder, what effect has that been studied? Anyway, that to me is the crucial difference.
Yeah, that's a good question.
I have a feeling that undefined behavior was super relevant when C was designed, and it's super not so relevant anymore. There's 6.5 billion lines of open source C code, according to openhub.net. I'm sure most of it is not operating system code. Most of it is just code people wrote because they learned how to program in C. That's what I would claim. So my perception was the reason that C had a huge amount of undefined behavior even early on is they just, it was the 70s. You just didn't know any better. And then as time went on, we still didn't know any better as far as developing usable, static, or even, I guess it would have to be static checks to make sure you don't do the wrong thing. There's been tons of kind of post hoc, make a static analysis, make a verifier, or whatever to make sure your C idioms are safe, even though the type system doesn't help you out. But I like your point of view of, I do think that C there's an ethos there of trust the programmer, that there are ways to write, this kind of thin veneer over assembly code that are safe, trust them to do that. And that mindset probably goes right into everything that they end up doing, right? That, when the type system gets in your way, no problem, do an unsafe cast, you can get around it. Whereas when you come at things from a type safety perspective, you think a little bit differently, that the type system is your friend and you don't want to get around it if you don't have to. And certainly that's the Rust perspective, right? Unsafe blocks are very bad.
Right. Getting to the questions, some strategies I could imagine. I think that they're different for different questions. One question is how undefined is C code right now in practice? So you could imagine doing a kind of a repository mining study where you look at some of those trillions of lines of code in C and the language spec that says where things are undefined and try to determine them. Of course, I guess you'd either use a static or a dynamic analysis to find those places, and it might be hard.
It is undecidable, of course, but anyway.
It's undecidable when it's undefined. Okay, so that makes it especially hard.
You can approximate that.
There's a separate question of how much trouble that causes people, and I guess that's a place where maybe you find bugs in that database based on undefined behavior. Simplify it, put someone in it in a lab study, and see how they deal with it. Then there's Michael's question, which is I think a very difficult one. So we actually worked really hard to make Obsidian simple enough that we could teach it in an hour-long tutorial. And we also worked really hard on that hour-long tutorial to make sure that we could give people a certain amount of facility. And we succeeded in getting people to write small snippets of code like what Michael showed you plugging in. We did not succeed in having people design abstractions with type states that were complex, like having a casino that contained a game and have the state of the casino depend on the state of the game, like correlations between type state of two variables. So I think my impression was that would probably take longer to get people to that facility. Well, Rust is an entire level beyond that, of course. So you might have to go to a different, more longitudinal design. You might have to go into an educational setting where you have a student for a semester. But I could imagine applying some of the same techniques, maybe to a subset of the class that opts in, or find less invasive ways of doing them with the entire class, again, with or with a subset that gives you permission. But yeah, I think it's super interesting to think of, one thing that HCI people think, and I'm not originally an HCI person, but I'm learning some of the lingo, is what are the barriers that people face, right? What are the barriers, the conceptual barriers that make Rust hard? And of course, this is something we think about as educators anyway. And the HCI folks have come up with maybe more formalized ways of studying it. So if you can determine what those challenges are, maybe you can then design interventions, ways of teaching Rust, particular exercises that kind of expose people to those challenges and get them past them. Maybe changes, if you were a Rust designer, you could think of changes to the language or alternative designs that could lower those barriers. Those are ways that I would initially kind of think about that problem.
I like your idea of the longitudinal study. I mean, maybe the same thing would apply for learning functional programming. That if people come at programming from, oh, I learned Java, then I learned C, oh, now it's time to learn functional programming. Okay, so you have this, you know, a year and a half of background, and what are the barriers that you face? And you could just watch people. Maybe you teach them over a class. You could be systematic about where they get stuck, and maybe that would reflect back on, say, error messages or other language features or something like that.
We talked about several things, actually. We talked about how you would study the usability of Rust, which is challenging because it's very complex. It's, you know, we felt like Michael and I mentioned that Obsidian was a complicated language designed to study that require multiple hours, but Rust is much more complicated even than Obsidian. So we talked about maybe doing that over time in a longitudinal study. Where you teach concepts over time in a class and you do things like think aloud, or maybe you instrument some students' environments with their permission to gather data, and you try to find barriers, right? And then you can look at what are interventions you can use in teaching that help get students over those barriers. Let's see. We talked about teaching closures and how you might learn to teach, figure out how to teach constructs like closures more effectively. We talked about how to find, you know, interesting tasks for that. And in that case, of course, we have tasks that the students are already doing in class, so that's maybe easy. But you can then take those and do think alouds. We talked about techniques you can use in think aloud studies, like you know, if you want to find out what are people spending their time on when you give an error message in Haskell, when they deal with an error message in Haskell. Well, you could have them think aloud, and then afterwards you go to the recording and you look at you know, what is the comments the person utters? What does that reflect about their inner mental state, right? And can you divide that up into thinking about understanding the error message, understanding the program context that informs the error message, you know, actually fixing the error, maybe doing irrelevant activities, maybe code navigation. We mentioned eye tracking as a potential way of trying to understand what people are looking at and thus get additional insight into what they're thinking. Anyway, so those were just a few of the things we talked about. Maybe others from the room can add if I left anything out.
Yeah, thanks. Anybody else want to add anything from that room? Yeah, we discovered in our room also that it's hard in 10 or 15 minutes to really nail down a particular problem, because first you have to figure out what the problem is, and then designing a task is a complicated process. Does someone from our room want to summarize, or should I do it? We talked about a variety of things. We ended up focusing a little bit on spreadsheets. We have, I'm sorry, I didn't catch your name. Your username is Lion Dance, but I think you said your name is something else. I didn't quite catch. Are you muted? I can't hear you.
Okay, here I am. Sorry, I was muted. I just sent you the text because we got teleported. I already sent you with a link to the presentation, to the conference. Again, please keep in mind, I am not a PhD even candidate. I have a master's in computer science. I literally learned studying type theory because I got myself into this rabbit hole and realizing I don't have the knowledge from the 80s. Lots of things even didn't exist then. This is my first functional programming language, and I designed it, so imagine that. Thank you.
Great, thanks, Enzo. So, right, so we're talking about the role of reactive programming in a spreadsheet, and what happens if you break the reactive programming paradigm, and how could you design a user study of that, and what kinds of tasks might you give? We were talking about kind of modeling and simulation kinds of tasks where you have some sort of iterate until convergence kind of situation. But then you can't really do that until you've taught people the basics of how to use your language. So you need some kind of tutorial in order to get people comfortable with the language and the IDE, because in a spreadsheet context, the language and the IDE are very closely intertwined. It doesn't make any sense to use one without the other. So that was kind of an interesting aspect to this problem. So do you want to add anything, anybody else?
There is a lot here that goes into the area of, I don't know, the teachability, like how you teach things, not just programming languages. Forgot the name of this researcher, actually, in the content spreadsheet. She's an expert on this, Felian Hermans, okay? I learned a lot by reading her papers. So I like something that Ian said, and I tend to agree with that, but again, my theoretical base is still very weak. I do believe that those loops, like talk about recursion or something with a fixed point, I don't think that breaks the reactive semantic. It's just, it takes a little longer to compute, but it's okay. Now, I'm thinking from the perspective of this tutorial, how we teach that? Well, it's not just for Lily. I'm sorry, I'm using the name of my language. I don't want to advertise it, but otherwise it's hard for me to talk. It's not so much teaching. How you do recursion is Lily. You need to teach about recursion, right? And what I will do there, I tap into time-honored tradition with Abelson, Sussman, whatever the guy's book that I started reading last year, by the way. I didn't learn Lisp, and that's big of proud of my shortcoming. That, well, you maybe start with a factorial or something stupid, right? So I'm actually, my solution, or not solution, my approach to the usability question and try to make something that people want, like a what coming on, make something people want, right? Those are the ones I would love them to fund me, because I don't have enough money. I've been funding this research, pay students, okay, and do most of the coding myself anyway. The thing is that spreadsheets have already been proven successful, right? And that's why Simon Peter just the other one hanging in there. And the power I break with the tradition, actually, I decided to break a little bit that symbiosis between the IDE and the programming language underlying, which you mentioned, and that seems counterintuitive. Say this is what they are successful, people in academia, so because there's a concrete representation, you work with that. Well, so that would be a nice hypothesis to test, because my hypothesis, and by no means I'm not convinced it's true. Okay, like they say, it's a hypothesis. In my case, actually, I have skin in the game. If this hypothesis is wrong, I wasted 10 years and money to find that it was wrong. My hypothesis is that the entanglement of the model and the visualization is the root of most evil, second only to A1 notation on spreadsheets. Spreadsheets have a very low barrier to entry. You pretty much in not say 5 minutes, but in 20 minutes, you can teach somebody to use a spreadsheet pretty effectively, right? And then what they find, people are very smart, very good in math, and I see this in the financial industry all the time, they reach a ceiling. They reach a ceiling where they need to do something that they need to have a stateful transformation, etc. And they know, they realize, they say, oh my God, I need to go VBA. And that's the moment they say, I need to learn programming. So there is consistency, I think, both in academia and in the world out there about what people assume, like what it means to be a programmer, right? In my work, but I don't tell people, I call them non-programming end users. To me, they're programmers. They're just programmers that are crippled by the ceiling. They have what they call the spreadsheet core. That's a very important concept. My idea is like, there is a spreadsheet core, and then we plop stuff on top because at the ceiling, okay? And it's sad that nobody has explored. I mean, this is my reaction. Nobody's exploring the route of generalizing that core. And actually, you know, like when you look at Lisp, but from a semantic perspective, and unfortunately, I didn't know Haskell. I think Haskell is ideal. And there was a project, a master's thesis called Haskell, where they put an user interface on that. Problem is, they do not generalize the spreadsheet core. You give that to a spreadsheet practitioner, and they say, this is not a spreadsheet. Instead, you show the Zen sheet to a spreadsheet practitioner, okay, with some things that were missing, and they say, oh, yeah, it's a spreadsheet, because the A1 notation is there. They can insert rows and columns, etc. You think, oh, you just plop then functional programming with worksheet. No. There is a type system there. Worksheets are two-dimensional arrays of lazy variants. That's why I claim, that's the only point of pride, I may have been the first to propose that generalization. Okay?
this is all really neat. Thanks. There's been a lot of work done on different ways of generalizing spreadsheets. Like take a look at the Forms 3 work from Margaret Burnett.
Can you send me the links, please? Because I always, yeah.
So I think we should move on.
Yes.
We can talk about the other things. So after you've done after you've had your participants complete the tasks, you should probably do a post-study survey. This is useful for collecting quotes that you can use in your papers, and to assess whether people liked it, and just to get insights about how the experience was for the participants. So this is one example. How much did you like the language that you used? How well do you feel you understood particular concepts that we were teaching you? How useful were those concepts? And then do you have any additional comments? And then this field was used for recording which condition of the experiment they were in. So S and O or just different conditions. So this is pretty useful. We got a lot of interesting comments, and some of our reviewers in one of our papers explicitly asked, in a paper in which we didn't do this, they asked, for it to have been done. So we were glad that in this experiment we had done it. Now, how many participants should you have? In a usability study, you can keep going until it's not useful anymore. That is, until the things that you're learning seem like they're mostly repetitive and you already knew those things from the previous participants. So typically in a usability study, you work with one participant, you learn about some problems that you found either with the materials or with the prototype. You fix those problems and then you repeat. And the idea is any problem that people encounter is likely to be a problem that other people will encounter. And so you might as well fix them right away rather than waiting until you see that it's a common problem. In the meantime, though, when you have a participant who encounters a problem, you'll need to help them work past it. So this doesn't work if you're doing a quantitative study. You can't argue that A is better than B if you gave people with A in the A condition a bunch of help. On the other hand, if you are trying to identify usability problems and you give people a little bit of help, well, okay, you identify one problem and then now you can get past that and work on the next problem. If you don't, though, if you don't fix the problem, you can then measure to see how frequently problems are encountered. And depending on what your research goals are, that may or may not be interesting to you. So, okay, that's good. But maybe you only have a language prototype. You don't have an implementation yet. And you'd like to do some work to try to understand what usability challenges you might have before you go about building out the full language. So I want to share with you some techniques that we've used in order to address this kind of problem. One of them is called Wizard of Oz. So the idea is you have an experimenter simulate incomplete parts of the system. So for example, we didn't have a compiler yet, but we had an experimenter who could provide simulated compiler error messages. Now, obviously, these error messages could be substantially better than real error messages. But on the other hand, if the participants still had trouble, even with really good error messages, that was an even better indicator that we needed to fix something more fundamental, rather than just saying, well, if only we had better error messages, they would have understood this. You can also, if you record what error messages you're giving people, you can try to keep track of what error messages are helpful and not helpful, so you can actually write good error messages.
Yeah, just to add to what Michael's saying, if you want to do this, sometimes this is fine to just do informally as you're exploring the language and the error messages. But if you want kind of repeatability to your study, then you can write down the messages ahead of time and only use the ones that you've written down. And if at some point, maybe you realize you made a mistake and you need to give an error message that you didn't think of, well, write it down right then and use the same one the next time, right? Or you can even refine them over time and track that. But then, of course, your runs aren't necessarily comparable, but with a qualitative study, maybe you're not looking for comparability so much as just improvement.
And one observation is a lot of IDEs provide real-time feedback with error messages. So they're compiling very frequently, even when the user doesn't say explicitly to compile. So it's legitimate to interject with error messages in the middle, because an IDE would do the same thing. Hey, you've got an error over here. As opposed to waiting until I tell you, hey, pretend you're compiling, and then give me all the error messages at the end. And so you can give any kind of programming task this way, as long as they don't actually have to run the code. So, fill in the blank or write this large program. All those things you can do this way. Obviously, the error messages that you give will be imperfect. For example, you might miss certain errors that are, that a real compiler would give. But it's an approximation. The goal is not to show that your system is good or better than some other system. You can't do that this way. But if you want to identify some key usability problems early, this is one approach. Natural programming might be useful in a situation where you want to find out how people naturally specify software without being trained in any way. So yes, the outcome will depend on people's prior experience. So one approach is to find people without experience. For example, natural programming was originally developed on a programming language with children. So they found children who had never programmed before, and they asked them, hey, if you're in this situation, what would you tell a computer in order to build this piece of software? What we did is, we recruited programmers, but we put them in a novel situation where no existing programming language with which people were familiar, had language constructs to capture the particular characteristics we were giving them. And we told them, look, please be creative and use any kind of language you want in order to specify the solution to this problem. But of course, you have to constrain their choices somehow. And if you constrain their choices, that prevents them from just using existing approaches that they're familiar with. So for example, we gave 7 participants a description of a voter registration system. We said, please implement the system in pseudocode using any language features you want. 2 invented syntax denoting states and state transitions. We were interested in building a language around state machines. So, out of 7, 2 is not large. On the other hand, it suggests that, probably some additional people would have been comfortable with that approach if we had suggested it, right? These are people who invented it kind of just based on their experience. Also, many of the rest of the approaches that people used were unsafe. Like, for example, they had separate lists for unregistered and registered voters, which means that a voter could appear on both lists. Another thing we did was after we did that, we said, okay, here's a state diagram that models the system. Please modify your pseudocode to use states and state transitions. And then even for people who didn't invent state machines by themselves, we could see what kind of syntax they would use to describe those concepts. And 2 participants had explicit state blocks with variables nested inside. So that was some amount of indication that that approach would be natural for people. Now, you can argue that you don't care whether it's natural for people. You're going to train people up, and it doesn't matter. And that's perfectly fair. On the other hand, if it is natural for people, and you can do it in that way, then maybe it's to your benefit, at least in terms of usability, to do so.
Perhaps you might save yourself a lot of time in training, for example.
Yep. Another thing you can do is, suppose you're designing a feature for a new language, and you'd like to either analyze a particular approach that you're considering taking, we'll call it A, or there are 2 approaches that you're considering, A and B, and you're not sure which one is better. And so your overall plan is you have this language, you're going to add A to this existing language L, or maybe you're going to add B to L, and you're not sure which you want to do, so you want to do some kind of user study. And if you teach people, let's say L plus A, and people get confused while doing one of your tasks, then it's not clear whether the problem making for now, or it was something about the combination. So an approach that we've taken to address this is, instead of doing the study in the context of your fancy language L, take A and add it to a standard language that people are already familiar with. So for example, we were interested in assessing the usability of type state. So we could have tried teaching people Obsidian, which is a language with type state, but we would have had exactly that kind of conflation problem that I was describing. So what we told people was that we were adding type state features to Java, and we recruited Java programmers. So not because we particularly cared about Java, we didn't, but because we could recruit people who knew Java, and we could kind of backport our design ideas into Java in a believable kind of way. And in this context, rather than implementing a type checker in Java, we used a Wizard of Oz approach to cut down on the implementation time. Because again, we were looking to implement Obsidian, not an extension to Java. So a bunch of work implementing an extension to Java would have been sort of throwaway work for us, just for the purpose of running the user study. Whereas this way, we could run the study much more cheaply, at least in terms of software engineering time. Any questions about those ideas? Okay. Now I want to talk more generally about other kinds of qualitative studies you can do. In general, when you're doing a qualitative study, you're working with kind of deep or verbose data. So you might conduct interviews with participants to try to understand what areas of their expertise you can leverage. You might do some direct observation. You go to someone's workplace and you watch them doing their work. The classical example of this is you're interested in helping people in an office. You go and you watch them in the office doing their work, and so you see there's somebody who enters a bunch of information in a form on a computer, and then prints out the results on paper, and then puts the papers in an inbox for somebody else to process. And if you ask them what the problems are, you might get answers like, well, sometimes the printer runs out of toner, and sometimes other people use the printer, and my job is get mixed up with their job, is that kind of thing. And then you go over to the other person and you watch them doing the work. And what do you see? Well, they take a piece of paper from the inbox and they put it next to their computer and they type it all in, right? So, the problem is that they have this whole wrong workflow where they're printing things out and then typing them in, right? Whereas if you ask each individual what the problem is, you'll get low-level answers like toner and, sometimes the box where the papers are, that gets full, and I wish I had a bigger box, that kind of thing. So by actually observing people doing the work, you can make much higher level inferences about what would be good approaches for them. You might get written documents like bug reports that you're going to mine for data. And there's a book on qualitative research by Patton, and he has this quote: "Research like diplomacy is the art of the possible," which is to say, you have access to some data, so it may not be exactly the data that you would have obtained if you could have obtained any data, but that wasn't an option, right? You have what you have access to, so let's figure out how to leverage it. So in an ethnography, you would immerse yourself in an environment, and you might produce very long-form results, like a book. So, if you want to understand what it's like to live with people in a particular village, you can go and interview the people there, but if you really want to understand what it's like, maybe you should go live there with them and basically become one of them. So this is obviously a very large investment in time, but on the other hand, you can get much deeper results and a much deeper understanding of what it is to have this experience than if you just talk to them and then tried to write down the answers. On the other hand, sometimes talking to people and writing down the answers can be very productive, particularly if it's an area in which you have some existing expertise. So you should prepare questions in advance. The kind of interviews that we typically do are called semi-structured interviews, meaning you write down some questions and you ask them kind of those questions, but you're not restricted to only ask them those questions. You're not restricted to only ask them those questions in that particular order. And you can follow up and ask them about their experiences and try to learn from their expertise. So you can include probes in your plan, things like, how do you mean that? And tell me more about that, right? But by having sort of general probing questions, you avoid biasing people toward, whatever you were thinking they might be trying to say, but also extract more information from people, because people sometimes are not as verbose as you were hoping. You should ask for permission to record the interviews so you can go back and analyze them later. You should phrase questions neutrally. If you ask them, functional programming is great, right? Then you'll probably get answers about how great functional programming is, which is maybe not as useful as a question like, tell me about your experience using functional programming. And then they'll tell you both things that are great and the things that aren't great, which might be more useful for your research. And finally, if you progress from general kinds of questions to specific kinds of questions, then you can collect information about your specific things without biasing them in that way initially. So I'm not going to make you read all of these examples, but this is a kind of a script that we used for doing one kind of study. So we started off with kind of general questions, like how long you've been programming. Let's talk about changes that happen in state. What about concurrency? Have you tried using immutable classes, et cetera, et cetera. So you can see how it goes from kind of broad questions to specific questions. I think we're going to skip this. So I'll encourage you afterward to try writing some interview questions and think about what questions you might ask experts. And an expert here might be just a student. The point is, it's somebody with some experience or some expertise that you're trying to extract from them. So if you're interested in debugging tools for functional programming languages where the programmers are students, then maybe you're interested in what the students' experiences are. So you have to think about your audience too. Once you've done some interviews and you've identified some findings that you think might generalize, you can use surveys to try to address, to try to understand to what extent these problems occur out in the world, right? So you can interview 5 people, you can interview 10 people, you probably can't interview 100 people, but you can survey 100 people. So if you observe, among your 5 interviewees, one issue came up twice, and you want to know, is this a serious problem that I want to conduct research on? Or did I just happen to encounter 2 people who had this problem? You can do a survey. So select a population, figure out how to sample from it. You don't need a lot of responses if you're trying to gather kind of long-form data like textual answers. But if you're looking for quantitative data and you're trying to do statistics, you may need a lot of participants. And I'm not going to try to teach you in depth how to do survey design. It's a complicated subject, but I want to give you a little hint of why survey design is hard. So here's a question. During how many days last week did you eat pasta? So I'll give you a minute to think about this question yourselves. How many days last week did you eat pasta? It's kind of hard, isn't it? Right? I mean, you may not remember exactly what you had for lunch yesterday. And thinking about, all of last week, let's see, what did I eat last Friday for dinner? You could sit there and try to figure it out. And it's a well-formed question. I mean, there is a well-defined answer to this question. People know what pasta is, and last week is a well-defined period of time. But somehow, if you ask this question in a survey, you're not likely to get really good answers. People are going to say, I don't know, maybe 3 days. I eat pasta sometimes, so 3 days, right? And, it's hard to know, even though you got concrete answers to your survey question, it's hard to know how valid the results are. Is it really 3 days, or did people kind of guess? Another question. If you ask, how many feet tall is your horse? Okay, this is a perfectly well-defined question. A feet is a valid unit of distance. I'm assuming here that we're talking to people who actually have horses, so that's fine. But it turns out that horse height is not measured in feet, it's measured in hands. So even if you're in a locale where, feet is a natural unit of measurement, and people all understand feet, and they all have horses, they may still not know how many feet tall their horse is, because they only know that it's 15 hands tall. They don't know how many feet that translates to. Okay, I don't know horses and I don't know hands, so I have no idea if 15 hands is a reasonable height for a horse, but you get the idea. Okay, what businesses would you like to see in the Moscow area that are currently not available? So they tried this, they got 1.8 different answers on average. Okay, fine. Then they asked as a follow-up question on another page, are there any others? And they got an average of 2.4 answers. Okay, well, that's kind of bizarre. I mean, they didn't ask an additional question that had any additional content. They didn't give any additional prompts. Here are some categories of businesses. Can you think in this category? No, they just said, are there any others? And they still got more answers. And so this is an interesting strategy, right? But notice how they didn't ask, how about a Taco Bell, right? Because that would bias the results. So my main guideline for you is to run pilots and consider, reading guidelines like from a book. This is one book on surveys that I found useful. So you can sit with somebody while they fill out your survey and listen to the questions that they have about the questions that they're being asked, and find out which things were confusing and which things they had trouble answering. All right.
I would mention, just to break in here, I think surveys and interviews are relatively new applied to programming languages. But I have seen a number of them, and maybe especially surveys applied in software engineering. It's fairly frequent. I've seen it in large companies, places like Microsoft especially, but maybe Google as well, where researchers in the lab arm of the company will survey developers on the development side to find out what problems they're having or what tools they use, or basically something that's relevant to research in this area. So those are the kinds of questions that I think maybe they came up first in software engineering because they're very natural to ask about tools and techniques and processes. But some of that kind of information could be relevant to designing programming languages as well. So it's worth thinking about as one potential tool in your toolbox.
Mike, you have a hand raised.
Right. So I'm just stepping back and thinking of community values. So like if we imagine, let's imagine that the 15 of us in this call do or plan to run out and apply these ideas in our research. I have a sneaking suspicion that if you write in your paper that you did a survey design where you iterated 3 times and to come up with the questions, that you did several qualitative usability studies to develop your language, that these things won't necessarily be valued by the reviewers of your paper. And ideally the community will say, oh, I'm more likely to believe this paper's result because it's backed by this process rather than it sounds good to me, so I'll take it. So this is just a comment. You don't have to respond to it now, but maybe it's something to discuss at the end, that if we believe that all of these things improve the quality of results, how do we get others to believe them too, so that they start valuing using these methods in our research?
Yep. Yeah, this is a really good question for the community. What we have found in part is that reviewers are typically not convinced by the results, at least in the PL community, or not convinced by the results of qualitative studies. They want to see the result of the quantitative studies at the end. So if you say, I did all this work and it led me to these insights and now I have a tool that I can show works, that's much more compelling to people than saying, I did this work and I identified the following problems and now I think my tool is better, but I'm not sure. Richard.
So, okay, there we are. You know, there's a really interesting thing that Mike said there, which is, if we believe these studies are helpful, do we have evidence that these studies are helpful? It certainly looks like they should be, but is there a sort of a standard reference that we might point to that says, okay, here are cases where qualitative studies have been done that have then been backed up by quantitative studies, for example, so that if we're in a position where we can, say, afford to do the qualitative study but can't afford to do the quantitative study, for broad meanings of afford, that we could say in a publication, no, we haven't done this, but this citation says that if you follow these techniques, there's, you'll have improved your result.
Yeah, that's a good question. Unfortunately, there are no guarantees, right? There's no guarantee that even if you do a qualitative study and you make some changes as a result, that the language is going to be better, right? The HCI community generally accepts that qualitative studies are a good way to find serious usability problems. But I don't think it's accepted that if you do qualitative studies, then you definitely have a good system afterward.
Yeah, of course that makes sense, right? Just doing a study isn't going to improve things. But you say the HCI community has this sort of general understanding that qualitative studies are good. Is there a way to point to the, that sort of, you describe it as sort of a folklore knowledge. Is there a way to point to that information somehow?
Yeah. Unfortunately, these, what you might like to do is recruit a bunch of, program language designers, let's say, and do a quantitative study where you have some of them do qualitative studies or whatever other method you're interested in, and some of them use their traditional methods, and they all design programming languages, and then you do a quantitative study comparing the resulting languages from the group who used the methods and the resulting languages from the group that didn't use the methods. Nobody has done that, at least to my knowledge, and I think it would be a really challenging kind of study to do with so many variables. And likewise in the HCI community, I'm not aware of, I'll say, quantitative work that has been done on sort of comparing quantitative results of design artifacts. There has been a bunch of work asking the question, like, how many participants do I need in my user study? So they'll do things like, they'll build a system, they'll do a user study, and they'll watch how many new problems they find. And so you can see, the first participant identifies a bunch of problems, and the next participant identifies not as many problems because you fixed some of them already. And then et cetera, et cetera. Every new participant is likely to identify fewer problems than the previous ones. And then you have kind of a cost-benefit question of how long should I do this? how many problems will I try to find? And then if you do fix a problem, will you introduce a new problem in the process? So that kind of work has been done, and so there's data on that. Briefly, the answer is like 3 or 5 or 15, depending on where along the curve you want to be and how complicated your system is.
I'd add a couple of things to what Michael said. I think it's a great, first of all, it's a great question and a hard one. It's a social engineering of the research community question. I'd say 2 things. First of all, obviously it'd be nice to do the experiment on qualitative studies that Michael describes, but as Michael said, it's obviously difficult to do. I think we should recognize that there's other forms of evidence that even we use, right? So with programming languages, one way to validate a programming language is to build a big system in it, right? Traditionally, the compiler for your own language, but maybe you might branch out and build an application that's in the domain that you're targeting. And if it's an especially large application, and if you can show that your system is much more concise or enforces, interesting properties of this large system, then that is a form of evidence that your language is useful. It is much different from an A versus B experiment with humans, but it is a form of evidence. And I think we have the same form of evidence. When we did, so I'll give you something that you can cite. Michael and I are working on a couple of papers that, one of which describes the qualitative techniques and one of which describes the quantitative technique at the end. Neither of those are published yet, so you can't cite them. But I did an earlier iteration of this with Joshua Sunshine. And as Michael said, we published a nice paper on the summative study showing our technique was useful. And then afterwards, we gave a different paper on the qualitative studies that showed us how to design that. So again, the summative study came first, which was really annoying, and no one believed the qualitative study was useful until we had the quantitative one. But now it's out there, right? So now it's it's one small piece of evidence that it's a case study, if you will, right? Showing that yes, you can apply qualitative methods to a programming language design question, and you can get evidence later on that it actually helped in the form of an experiment. So hopefully Michael and I will have another one of these in a few months, another one of these pairings. If all goes well with reviewers not to be named. So if we have more of those, we need more to do the social engineering. We need more volunteers, right? And it'll be a little bit hard at first. We may have to delay the publication of the qualitative stuff until we have the experiment in hand. But eventually, if we have a dozen examples of these, then I think that's what convinces the community that this is a useful thing. And useful here, again, that doesn't mean the end system is useful, but it means the technique is useful. And the contribution in a paper is, hey, we learned something about improving our tool. Those improvements might be useful for other tools that are maybe similar to ours in some way. Michael, you have your hand up.
Sorry, we're hijacking the tutorial. I'll make it brief. The thing that struck me at the beginning of what you guys were saying is, you are not your audience. And I feel like a lot of the time we PL people think of ourselves as our audience, but we're not. And so being able to say, I worked with real users in this way, even qualitatively, ought to be convincing. The question is, would you reject a paper that didn't have one of these? That's the sort of cultural question I wonder about. Yeah. And I think, an answer ought to be, quite possibly, you should. And the things you're talking about just provide evidence for why these qualitative approaches give you more confidence that when reaching outside of your own intuition, this method works.
Yep. It also depends a lot on the particular contribution that you're trying to make, right? There's nothing wrong with publishing or submitting and publishing a paper that describes a particular formalism that captures something that wasn't captured before. You don't need any kind of qualitative studies for that sort of contribution, right? But if you want to argue that you're designing a language so that you can make something easier or your language is more usable, that's a case where you need to do some kind of user study of one form or another to provide some kind of evidence. Okay, your hand is still up. Are you done, or did you? Okay, good. Okay, very good. I want to talk very briefly about grounded theory. Some people who are not familiar with qualitative methods sometimes say things like, well, this qualitative stuff, that's not really scientific. And so I don't want to hear about your non-scientific mumbo jumbo in my scientific context. So, you leave that to the psychologists, and I don't want to hear about it. And what I want to mention here is that there is a collection of formal methods. By formal, I don't mean mathematical. By formal, I mean structured and well-defined for analyzing qualitative data. So if you collect a bunch of qualitative data, you might like to find some themes in the data and develop some theories. And again, we'll leave it to quantitative methods to try to address generalization questions like, in what contexts does this theory apply? But if you'd like to develop theories that are based on data and not just from your own brain sitting by yourself, then you might like to leverage some data, and you might like to use a structured mechanism for analyzing your data so that you can hope to say something beyond, I stared at the interview results and this is what I felt, right? Because that's not very convincing. So this grounded theory approach is one of several different theoretical approaches for analyzing quantitative data. So the idea is you observe some phenomenon. Let's say you get an interview transcript from an interview you did, and you record events. Let's say it's statements that people make in the interview. And then you code the events. And what this means is you develop a set of categories for the events. And open coding refers to the idea that you don't know in advance what the codes are. You don't know what the categories are in advance. You read them and you try to put them in buckets. There are various techniques for doing this, like with lots of post-it notes. But in short, the idea is you try to categorize things and you see kind of how often, what themes come up and how often those themes come up. And then after that, you try to think about relationships between those codes. So for example, this is an example I pulled from the website you can see at the bottom. What irritates or upsets millennials when receiving feedback on their work? So they did some interviews. People said, if you look at the rightmost column, that describes what people actually said. For example, getting ripped apart, chewed out, bashed, chastised. And then the code that the researchers came up with is in the leftmost column. So they put all these in a category that they called getting called out. And then this properties column kind of defines the code. Again, not in a mathematical way, but in a way that a reader could try to understand what this code might mean. So you can sort of see what issues are coming up among the millennials in this study, and then think about what you might do in order to address those. There's a lot more to grounded theory, and we don't really have time to get into the details, but I'm just trying to show you that there are structured methods that you can use if you're interested in analyzing this data in a way that's more formal and more organized than just like, I stared at it and I thought something and here's what I thought. At the same time, there's a recognition that this process is somewhat subjective, and the context and the experience that the researcher brings is relevant. And so when you report on this kind of work, you try to suss out that kind of context as well. Okay, so I want to end this discussion about qualitative studies and move on to quantitative studies briefly. My main recommendations for you are do lots of pilots and revise your study after each one because you will find problems. A narrower design question or research question is much more likely to give you useful user study results than a broad one. If you try to do a user study on object-oriented versus functional programming, that's probably much too hard. You need something a lot narrower. Phrasing your usability questions specifically is a really critical step. So you can design tasks that address the particular kind of usability question that you have. You can't just say this thing is more usable than that, but you can say it's more learnable, or it tends to result in people completing tasks faster, or it allows additional kinds of people to complete tasks who couldn't complete them before, that sort of thing. And then design tasks for those kinds of usability problems. And again, iterate to design good materials. Any wrap-up comments about qualitative studies before I move on to quantitative studies? I'm not sure, so maybe I'll do a little interview with each of you. I have a few questions here, and then we'll see. No, okay, I'm not going to do that. Okay, so now I want to talk about quantitative studies. And the key differences relative to the qualitative studies are we're going to leave the participants alone. We're not going to interfere with them while they do their tasks or help them. We're not going to change anything between the trials. So we're still probably going to give them some tasks. Maybe they're programming tasks. Maybe they're design tasks, some kind of tasks. We're going to collect some data while they do those tasks. And then we're going to do some statistics. So I'll give you some sort of basic vocabulary to think about these things, which many of you may already be familiar with. As the experimenter, you choose some independent variables that you're going to adjust. For example, you can assign participants to languages. These are also sometimes called explanatory variables because you're going to try to explain the differences in behavior that you see on the basis of these things that you selected. So you're going to typically assign these things randomly, and then you're going to measure your dependent variables, let's say task completion time, or number of bugs, or what kinds of bugs people inserted, that sort of thing. But then there are also these confounding variables that also affect the dependent variables, which you may or may not have thought of, but which make the experiment kind of harder to interpret. So for example, we built this language Obsidian, we were comparing it to a language Solidity, and we wanted to know, are Obsidian users more likely to insert a particular kind of bug, asset loss, in which they lost things of value like virtual currency? Are they more likely to do that than Solidity users? So the independent variable is the programming language used. We could assign people to use a particular programming language. And then we measured whether assets were lost based on looking at the code and determining whether that particular kind of bug was present. But then a confounding variable is programmer expertise, right? Maybe people with more experience programming don't need the additional safety features in Obsidian. So you can basically control for them by, say, recruiting narrowly. You can recruit only people with a particular kind of programming expertise. Or you can record them and then try to do statistics on whether they affected the results. And notice that if you don't realize a confounding variable is present, then this can really influence the interpretation of your study. So you have to be careful about this. So back to the example, we assigned some people to use Solidity, we assigned some people to use Obsidian, and you'll see if you look, 7 of the 10 Solidity participants lost an asset in either of 2 subtasks, and none of the Obsidian participants did, because of course Obsidian rules out this kind of bug statically. There's an asterisk there, which we can talk about later if you're interested. Turns out you can abuse the type system in order to defeat it. But the point is, everybody in the Obsidian case did it correctly here. That is, everybody who completed the task was able to avoid this particular kind of bug. And 7 of the 10 Solidity participants made this mistake. So this is kind of what I was getting at earlier about seeing whether a bug that you're wondering about actually occurs when you ask people to do a programming task, right? If the outcome had been neither condition makes this mistake, then you might ask, well, why did we bother going to all this trouble to develop a language that prevents this mistake when nobody makes it anyway? Right, but here we showed that people actually do make this mistake, at least in the lab. We can do a statistical test between these 2 results. Fisher's exact test says P is about 0.002, which means there's about a 0.2% chance the likelihood of asset loss is the same in the 2 conditions. Think of this like coin flips. So you and I are each have a coin, and we're flipping coins. And each coin is weighted. We don't know what the weight of each coin is, but we want to know whether the weights of the 2 coins are different. Each one has some probability of getting heads. We don't know what it is, but what we want to know are the 2 coins different? Or are you more likely to experience, in this case, a bug in one condition than in the other condition, without regard for how likely it is in the first place? So in general, this is called hypothesis testing. So you're drawing from 2 populations, and you want to know what's the probability that the 2 populations are the same. This is what p-value capture is. A really important distinction here is that p-value capture is the probability that the 2 groups are the same. It does not capture how big the difference is. For that, you need something called effect size. So you can go to an incredible amount of trouble to measure a very small effect. And maybe that's worthwhile, and maybe it's not worthwhile. So, I can't tell you in advance which it is, but typically if the effect is very small, then people are not very interested. In this case, the effect size is fairly large, but you can do a study and find that the effect is very small. And in particular, the reason you might need a lot of people in a study, a lot of participants in a study, is either because there's a lot of variance, people do have very different behavior, or because you're trying to detect a very small effect size. I'll talk about this again in a few slides. Otherwise, you need only a relatively small number of people, right? If you have low variance and the effect you're trying to detect is large, then you need a relatively small amount of people. That's how we got away with 20 people total in the study. Actually, 21. We had to throw one away. So there are generally two categories of quantitative studies. There are between studies and there are within studies. So in a between participant study, each participant gets assigned to one condition. So you're comparing performance of your participants between the two groups who are each assigned to different conditions. So this means that you can give the same task to the two different groups, and there's no learning problem because each person only sees one condition and only sees one task. On the other hand, you'll observe more variance here between participants, because if you recruit two different sets of people, well, not only are they different people, but they may be different demographically in an important way, right? So you assign people randomly, and then you find that on average, the people who got assigned to this group have more programming experience than the people who assigned to that group. And you can try to carefully assign people in a balanced way to map. And if you use the alternative approach, which is to say every participant tries all the conditions. So this is useful if you're doing a study on something that doesn't have large learning effects. So imagine you wanted to study whether people can click on buttons faster with a mouse or with a trackpad. So you get a bunch of people, you give each of them a mouse, you also give them each of them a trackpad, and you have them do a bunch of clicking tasks. And it stands to reason anyway that practicing with a mouse probably doesn't give you a lot of advantage with a trackpad, and vice versa. But just in case that it does, what you do is you counterbalance the order. So half of the people start with a mouse, half of the people start with a trackpad, and then you can see, is it substantially faster for the second set of tasks? And if not, then you infer that probably learning was not a significant effect. And then you don't have to worry about discrepancies between the two groups of participants because the two groups of participants are the same. They're the same people. For the Obsidian study, we chose a between participants design because if we gave people the same task to do twice, there would be a significant learning effect there. And if we gave people two different tasks to do, then it's sort of not clear that we have two different tasks that have the same level of difficulty. So that's why we chose that, and we accepted that there would be additional variance as a result. All right, now sample size. As I mentioned, the key questions are effect size and variance. So the official way to do this is to run a power analysis. You can find power calculators online, and they'll tell you, if you want to bound your probability of missing a significant result at some probability you can choose, then you need this many people, given that you expect this amount of variance, and given that you're looking for an effect that's this size. But in order to actually run this analysis, you need to estimate your variance and your effect size. So you can do this with pilot studies. That's a good use for pilot studies. Or you can look at past studies. Or you can say, look, I'm really only interested in effects that are at least this big. So I'm not going to try to measure the effect size that I'm actually going to have. I'm going to admit that if the effect size is smaller than this, I'm unlikely to see it. So in a typical HCI or programming language kind of study, you're usually looking for large effect sizes. And so that's why you can do these studies with relatively small numbers of people, as long as you can keep your variance under control. So, if you get 20 people or 30 people, that's kind of reasonable. The two quantitative studies that I've done were 20 people each. And, we had significant statistical significance for some research questions and not for others. And you can always say, well, the p-value we calculated was 0.1, and it's up to your interpretation as to whether you consider that a significant result, right? There's a 10% chance that these two populations are the same. It's very likely that they're different, but it's up to the reader to decide, what their interpretation is. The key thing is you can only generalize to your study population, right? So if you draw from students, it's not clear how your results will generalize to non-students. if you go somewhere and you recruit a bunch of people, and it turns out that all the people who you recruit were male, then it's not clear whether results generalize to females, right, or people who are not male. So you can argue on the basis of some theory that the results should generalize, and that may be acceptable. On the other hand, it'll be an open question, right? You don't have the data to justify that claim. So you have to be careful in your recruitment to recruit, from a population that you want to generalize to in your study. If you choose a population that's too broad, let's say all programmers, well, sampling from all programmers may be very hard, right? So typically what you do is you choose a population that will give you an interesting result this time, and you accept that there are additional populations which would be interesting to generalize to, but you haven't studied them, right? So for example, if you did your study on all adults, do the results generalize to children? Maybe, maybe not. You can argue that they probably do, at least for children who are old enough. But it's probably a worthwhile trade-off to make so that you don't have to go to the additional steps to recruit children. Because basically, if you want to recruit children, you have to argue that you need children in your study. You can't do the study with adults. And you may have a good argument, particularly if you're designing a programming language for children. But maybe you don't. It'll depend on your context. So there's a trade-off here, right, between low variance, low generality, and small sample size, and high variance, high generality, and large sample size. So you typically end up with high variance if you have long open-ended tasks, but that also can increase your generality, right? Because, well, real-world tasks may be long and open-ended. Likewise, if you recruit from a broad population, you're going to get much more variance than if you try to recruit from, let's say, only third-year students at University X. But in exchange for your additional effort at recruiting from a broader population, you'll be able to generalize to a bigger group. So as you move more toward the right in this table, you're going to need more participants. So that's kind of a question for you about what your goals are and what your budget is in terms of how much time and money you want to spend on your study. Okay, so I want to wrap up and make sure we have some time for discussion and questions. I want to return to the slide we had at the beginning about the suppliers approach. So we're arguing you should use user-centered methods in addition to theoretical methods so that you can iterate on your design in step 4, and also so that you can identify a good design space to be in such that you will be solving real problems that real people have. Some questions that we have been able to address using these methods, things like what parts of language A are confusing despite the training that we have? Are any users of some standard language likely to insert a particular kind of bug when doing a particular task? Try to base your tasks on real-world examples so that if people do insert the bug, it's not a contrived result. It may generalize to kind of real-world tasks. We can also discuss, can users of some language B complete task T about as fast as users of language A, right? So in the quantitative study, you may find that in your fancy language, it takes people a not significantly different amount of time to do some task as it does in an existing language, right? So it may be that there is a significant difference, but you haven't found it because you didn't have enough participants. Or it could be that there is no significant difference, and you're not going to be able to tell a difference between those two categories. However, it's completely reasonable to expect that there will be some cost to obtaining other benefits that your language offers. More expressiveness, additional safety, higher performance maybe in benchmarks, whatever benefits you're trying to accomplish in your language. So you can argue my language is better because it takes people maybe roughly the same amount of time, but it has these additional benefits. Or your language might be better because people complete tasks faster. That's entirely a language design question, but you can consider both kinds of questions in your work using these methods. Okay, now some kind of meta questions about this work. How do I know when I did these studies of individual features, and now I'm going to combine those features together into a language. How do I know that the results will be as advertised? We're saying you should do these studies of individual features sometimes, and then how do I know that when I combine those features together, you're still going to get good results? And my answer is, well, you don't. But if you don't get good results with one feature at a time, you certainly won't with a combination, right? So think of this sort of like a floor. So maybe do your work on individual features first, and then see what happens when you combine your design decisions together. And so you certainly need follow-up studies in order to address the combined language. Likewise, generality. Reviewers will typically say, that your tasks are too small, you don't have enough participants, you got the wrong participants, you didn't train them enough. And, the thing is, these objections will always be true to some extent, right? Like, there is never enough participants because you didn't recruit from a broad enough population. Some people who maybe are not as experienced with quantitative studies will look at the numbers and say, 20, I don't know, but 20 just doesn't sound like enough. I don't believe it. But on the other hand, we have to start somewhere, right? So in the future, more studies will be more general. Future studies will have more participants, different participants, more training, more expertise, larger tasks. But if you can start small and argue that your language at least has benefits for this collection of users, for this collection of tasks, that's much better than saying, I designed this language to improve people's lives, but I don't know whether it does. And this question matters less for formative studies. If you fix a problem for somebody, it likely fixes it for other people too, and then you're not trying to make these claims that have these objections. Okay, finally, does it do you any good to address usability problems encountered by novices? And I would argue that it does. In many cases, sorry, I should say cases, you can fix them without hurting the experts. And no one becomes an expert without first being a novice, right? And patience is limited, meaning if you give somebody your fancy new system and you promise to them it's going to be awesome eventually, and they never get to eventually, they'll stop using your system and they don't get any of the benefits. So you somehow need to get people over that, over that learnability curve. And if you can make it easier for novices without making it harder for experts, then why wouldn't you do that? And likewise, some people sometimes get used to, if you're an expert, you can get used to all kinds of suffering. It's like, why do I always have to do this when I'm in that situation? Well, I don't know, I've always done it that way and I've gotten used to it. Well, it doesn't necessarily have to be that way. And the novices can point this out to you much better than the experts who are used to doing whatever the workaround is. Right? If you go back to the inbox paper example, yeah, it's fine, I just put the papers in the boxes and it works. Well, it could be much better. Okay, so in conclusion, we've argued that qualitative and quantitative usability methods are useful in programming language design because programming languages serve as interfaces for people who are trying to accomplish real work. Qualitative studies can help you make major design decisions, for example, by suggesting new parts of the design space that you didn't consider, or identify problems in your design that you weren't aware of so you can fix them. Quantitative studies can also show the benefits of your design relative to the status quo, so you can actually argue that your language really does improve people's lives. So with that, thank you so much for participating. I've really enjoyed the discussion. I'm hoping we can talk more. So if you have any questions, now's a good time to talk.
Thanks, Michael and Jonathan, for putting together a great tutorial.
You're welcome. Thank you.
Thank you for attending. It was great to have your participation. Sorry, James, I talked over you.
No. I'm just saying thanks as well. Thank you.
Also, if you have any suggestions for future iterations of this tutorial, I'd love to hear those too.
I have one question. It's sort of related to what Mike said about social engineering in the community, which is if I sit here and I imagine myself going through this process, and I'm thinking I want to send a paper to POPL, I want to send a paper to ICFP, and I want to include one of these user studies, it seems difficult just because of space limitations, first of all, in a paper, right? So you want to include the theory because that's what's going to appeal most to the reviewers. And if you've done an implementation, which is presumably part of your user study, then you also want to include that. I can't imagine trying to fit an entire, detailed description of a qualitative analysis and a quantitative analysis. But I wonder if not including it would, let's say you do include it somehow and the paper gets accepted. Well, that's good because it sort of shifts the community in that direction. And then of course the other option is you don't include any of that information and you publish it somewhere else, right? You take the user studies and you send them to Kai and have a very brief description of the theory and the implementation or something like that. I wonder, what have you done in the past? Is there a better option? How do you handle this? Or maybe it's a non-problem that I'm just imagining.
Oh, this is definitely a problem. Yeah, the latter is kind of the route that we are taking in our current series of papers. Partly for the reason you described, where there's just not enough space to describe both in one paper, unless it's a journal paper. And partly because each community is expert at assessing a particular, kind of method or set of methods. I think I would like to get the PL community to a place where people don't make usability claims without evidence. And even if the evidence is not the contribution in that paper, maybe it's a contribution in a different paper. If you want to say that your language is easier to use, then you need to actually show that it is easier to use. Or alternatively, just say, we tried to make it easy to use, but we don't know whether it is. And then leave it to a different contribution or different paper to describe the work that you did. Now, the qualitative work, it could be that is not itself a contribution in a particular project, right? It could be, you did a bunch of work, whatever it was, to make the language good. And now what you're going to say is, look at this language, it's good for this purpose. And I did a quantitative study, and maybe you don't report on the qualitative work that you did, because that's not the particular contribution in that work. On the other hand, I think it would be really valuable to do qualitative work on existing designs and try to show that you can improve them. But again, the show that you improve them part, that probably requires a quantitative study afterward. So I think publishing just a qualitative result, I have not had any success with that so far. But if you pair it with a quantitative result, then I think that's where you get the bang for your buck.
Yeah, I think part of the... Sorry, go ahead.
I was just going to say, Michael mentioned journal. Obviously, that's one possibility. Also, if you publish at a conference first and you have an expanded version in the journal, qualitative studies might be one example of something you could add, and then the canonical version of the work actually has everything.
Yeah.
Yep.
I wonder too, in speaking of POPL and ICFP, with the move towards mechanization, it's made it so that, if you look at POPL papers from 30 years ago, the proof is a huge part of the paper, and they put it in the paper and they would, it's part of the page limit. And now it's like the proof is it's in an appendix, or even better or worse in some sense, it's mechanized off in some file somewhere, and you just mention in the paper, oh yeah, we proved it correct. And then people are able to just look at the language design, trusting that it's correct. I could imagine that a qualitative study could be similar, something that you expect to do. It's the initial usability claims that you're making. You're in the beginning part of your methodology, where you've gone through that iterative process that took you months and months and months to whittle it down to this core language design, which you think is interesting. So then you write the formal calculus, you prove the results, you send them off to a conference, and you say that, look, this design was meant to be usable. We did this usability study using the standard practice to give us confidence that it should be. Here's the formal results, quantitative results pending. And I would, as a reviewer, prefer to see that kind of paper to one that just said, oh, we made this stuff up, it's correct. The design for it is intended to be usable, but we have no evidence that it is. We'll pretend that we do, and here's the formal result. So I wonder if just saying that you did it without giving the details of it ought to be valued. And sure, you could then write a workshop paper or an appendix or something like that described it.
Maybe this is sacrilege, but I could imagine even just not even saying you're going to do a quantitative study. With the claims that people make in ICFP and POPL about usability, there's no study, right? So even just doing a qualitative study and saying we stared at some real people for a while and nobody does that. That's better, even if you just say I'm not even planning to do a quantitative study afterward. Maybe people will go, well, why? What's the deal? But yeah, I don't know.
Personally, I'd love to see this done with relaxed memory models to see which ones are more usable.
Oh yeah, that's a great idea.
watch and study.
Yeah, there's all sorts of hypotheses that for programmers find it easier to if you have sequential consistency, for example, right? It's plausible for sure, but wouldn't it be great to have some evidence?
We have a lot of heuristics that people use. So you'll see things like we made such and such a decision to improve modularity. And so therein lies two assumptions, right? A, that modularity is good for people, or good in general, and B, that this approach actually does improve modularity. And so I think there's a lot of latent usability claims and a lot of PL work, and I'd like to try to surface those. Because people make it sometimes it's sort of obvious, like, of course modularity is better. Well, modularity sometimes comes at a cost. So can we evaluate what those costs are?
You mentioned heuristics, and I agree. Heuristics related to programming languages are useful and important, and would be much more useful if they were validated. It's also worth mentioning that there are heuristics in HCI, some of which are relevant. For example, there's the cognitive dimensions of notations, which is a way of evaluating a notation for its usability. And so we have a couple of times in the past in my group used those heuristics to look at language design and try to make arguments about it, or try to understand where there might be problems. So I think more visibility of those heuristics, maybe more work on adapting them to the programming language setting and seeing which ones of those are particularly important, might also help give designers a very lightweight tool. A heuristic like that, it can never be a definitive answer that something's going to be more usable. But if you follow them, they often lead you in the right direction.
Yep.
And maybe they help you just ask the right questions.
Yeah, cognitive dimensions of notation are a great reference. I would encourage people to check that out if you're not familiar with it.
Yeah, I'll put it in the chat.
Alan Blackwell is one of the major proponents of that now, but originally Petra and Green.
So I've got a jet, but I appreciate the tutorial. Thank you both.
You're welcome. Thank you. Also, I'm happy to work with people. If there are particular projects that you're interested in pursuing, I think it would be neat to try to apply these methods to other language design contexts. So, shoot me an email if you're interested.
Thank
Absolutely.
you.
Likewise.
Yeah.
Thank you very much.
Very
Thanks,
good.
everybody. Great.
Thanks, everyone. Bye.
Doing this with you. Bye-bye.
Thanks very much. So long.
Bye.
Thank you, Michael and Jonathan. It was great.
You're welcome.
Thanks for coming on.